Hey, all dear champions, I, Abhinav Negi and Dheeraj sir, welcome you all again in this beautiful session of Strength of Materials, where we both will be taking 51 questions, 51 previous year questions of Strength of Materials from last year's of Civil, Mechanical and XZ. Guys, first of all, let both of us tell you that a question of previous year for mechanical or XZ is equally important for civil and vice versa also, because the syllabus is same. And if yes, 2% or 0.2% syllabus is difference, might be theory of failures or thin or thick cylinder especially, then we have not taken those particular parts. We have taken only those questions which are relevant for both the branches, guys. And these are not random 51 questions. These are those 51 questions that are defining the complete SOM. So guys, be ready, keep sharing the video, and guys, we will be providing the PDF of this super hit session on both the telegrams, that is mechanical by Dheeraj sir and civil by Abhinav sir. So guys, are you ready? Let's welcome you all. And guys, Dheeraj sir, अब आप मचा दीजिए कुछ.
So guys, I would like to add one point here. Whenever we are preparing for any competitive examination, then my dear, previous years plays a very important role. It is said to be, if we are going for last 10, 15 years, previous years, it is going to give you an extra edge over others. So guys, as sir have already told, we are not taking only for mechanical, only for civil, only for XC, but I would like to add one more. Some questions are also taken from P and I paper also. So guys, from all the 4 branches, we have taken the questions and you are going to enjoy, because they are the special hand-picked question. They are not like I am going with 2019 to 2020, not like that. From the first paper till the last paper, whatever the best questions are that we have chosen. So guys, these 2 hours, these 51 questions are definitely going to give you a confidence, as well as they will definitely increase some of your marks also. So be there, you would be learning some new things also in this session. So me and Abhinav sir would be completing 51 questions, and after the completion of session, we will be sharing the PDF in both the Telegram channel. So be there guys, and just like and share the session so that other students can also get benefited from that. Yes. Abhinav sir, over to you. Sir, आवाज नहीं आ रही आपकी आवाज. Mute.
So guys, this is about me, but this will not be coming in examination. We are coming with prediction series and Formula 1 series. Okay, from day after tomorrow, we are coming with this prediction series and Formula 1 series for both civil and mechanical. Okay, and then mock test of mechanical and civil on 22nd and 26th both. Exactly as gate pattern, that is 65 questions. Okay, and this will be, I will be telling you about the complete maths. And one more app session is also there. We'll be telling you about that at the end. Okay, so Dheeraj sir. Okay, yes, Dheeraj sir.
The last thing I would like to tell you that if you are preparing for GATE 2024, you want to you can get up to 90% of the scholarship. For that, you can appear on 22nd January for the scholarship test. 12 p.m. would be the timing. So guys, you can register here in the description of this session. So over to you, Abhinav sir. I feel now you can start the session. Then slowly.
Okay. Sure, sir. So guys, we are total 51 questions we'll be doing now. So we'll be taking questions like 2 questions or 3 questions I will be taking, then 3 or 4 or 2 questions Dheeraj sir will be taking. So in total we'll be doing the 51 questions. Okay, so एक करके लेते रहते हैं. सबसे पहले तो एक बार जल्दी से कमेंट बॉक्स पे सब के सब कमेंट बॉक्स पे सबके सब हार्ट साइन बना देना फटाफट से. गिव मी अ हार्ट साइन ऑन द कमेंट बॉक्स गाइस. दिस जस्ट गाइस बना दो यार प्लीज फटाफट से. Okay, so this is question number 1. हम question number लिखते रहेंगे. We'll be writing the question numbers. Okay, suppose I will stop in question number 2 or 3. Then Dheeraj sir will be taking from 4th. Okay. Okay, so Abhishek Sahu has put the hearts, guys. Come on, the civil champions, yeah. Come on, Swapnil, Naveen, everybody. So this, let me write it here. Question number 1. Okay, this is the previous year question of mechanical. This is the previous, guys. See, I'm not telling. I'll not be telling after this here that this is from mechanical, this from civil, this from this from this. I'm not telling, because of course, yeah, we have taken only those questions that are relevant for every branch. Okay, for civil, mechanical, XZ, for everyone. We have only taken those kinds of questions. So I'll not be telling again that this is for mechanical or this. Okay, let me tell you just that initially many of my questions were from mechanical, but that are equally important from civil. Okay, so guys, this is the question. A bimetallic means which is made up of two metals. A bimetallic cylindrical bar of cross-sectional area 1 meter square. Okay, the cross-sectional area is 1 meter square. Okay, sir, got it, sir. Phod denge question ko, sir. And made up of steel. Okay, this steel of Young's model 210 and aluminium of 70 gigapascal. 210 gigapascal, 70 gigapascal. Okay, sir. Okay, sir. Okay, sir. Now, to maintain axial strain of magnitude 10 की power minus 6 in steel. Okay, 10 की power minus 6 in steel and axial, this is to maintain axial strain of 10 की power 6 in steel and compressive axial strain of magnitude 10 की power minus 6 in aluminium. Okay, bhai, let me tell you first. इसकी क्या जरूरत थी कहने की? If this is the strain is 10 की power minus 6 in tension, then this will be 10 की power minus 6 in compression. Okay, तू क्यों बता रहा है भाई question? Why are you telling us? Because we know that the total delta will be 0. Okay, length are both same, so equal strain leads to equal deformation. So of course delta will be 0 because this is also fixed, this is also fixed. So if it is 10 की power minus 6 in tension, this will be in compression. Of course, yeah, no need to say this. The magnitude of the required force P. Okay, P should be P निकालना है भाई. So जब भी, whenever you will be seeing such types of figure which are both types fixed or beach mein in between there are some P force acting, then in such questions first thing you should be applying that, let me say this as A point, this is B point, this is C point, then delta AB plus delta BC is equal to 0. Why? Because delta AB plus delta BC is equal to delta AC. Many times this question, this type of compatibility equations are asked in previous year questions. That is the reason why I have taken this question. Okay. So now suppose this is P. I don't know where the steel reaction will be coming. Let me assume that here it will be coming, steel reaction will be coming here, and let it be RS. Okay. I don't know about aluminum. It can be in any direction. Let me, it is coming here, RA. If my directions are wrong, answer will be coming in minus. Now, to find delta AB, cut a section here. Cut a section here. See from left or right, your choice. Let me see from left. From left, RS is going away. Going away is positive. Delta AB, cut a section here. See from left or right. I'm seeing from left. RS is going away. RS into length is L by 2 into area of steel into Young's modulus of steel. Okay, sir. Now delta BC, cut a section here. See from left or right, your choice. Let me see from left. Okay, from left, RS is going away. So plus P is coming inside, so minus. So RS minus P into length is L by 2. Of course, L by 2 will be cancelled. Area is also will be cancelled. A is same. Into Young's modulus of aluminium, net value is equal to 0. From here guys, everybody guys, please be attentive on this session, because here we are not taking any 51 questions. These, as Dheeraj sir has told, this is hand-picked questions. So L has killed L, 2 has killed 2, area of both are same. Okay, area of both are same, so this will be cancelled and Young's modulus is given. Where, yes, Young's modulus of 210 of steel and 70 of this is given. Please guys, put answers on the comment section fast. Put answers on the comment section, guys. Okay, from here one equation and RS and P are the only things that are not known. Okay, RS and P are the only things that are not known, and from here everyone P value and RS value will be having a relation. Okay, P value and RS value will be having a relation. This is the equation number 1. Please let me know in the comment section. Have you understood it? Fast, everyone. And I guess here that relation, are you getting this? I have already calculated this, so you will not be wasting your time. That R steel is equal to 3P by 4. Have you got this? वैसे भी देख लो यार, RS is equal to 3P by 4. Okay, everything is given. I'm not wasting time. We will not be wasting your time in calculations. Are you getting this? Please let me know. Okay, now up from here, let me move further. Now delta of steel is equal to P of steel into L of steel into A of steel into E of steel. Okay, and delta by L. If I put this L here, if I put this L it is here, so delta by steel is L by steel is strain of steel, and strain of steel is 10 to the power 6, 10 to the power minus 6 in fact. Okay, and from here this is the P steel. Now see, A steel is given, that is 1 meter square. Young's modulus of steel is also given. From here, from this equation, see, A steel is given 1 meter square. Young's modulus of steel is given, so you can find P steel. And the value of P steel, what you are getting from here? What you are getting from here, please let me know, everyone. What you are getting from here is, are you getting 280 kilonewton? Are you getting 280 kilonewton? Everybody on the comment box. Everybody on the comment box, give me yes or no. Everyone got it, or only few students got it? Please fast. Please fast. Okay, this is the P. No, P steel you can write from P in terms of PR. See, P steel is 3P by 4 because we don't have to find P steel now. We have to find 3P by 4. We have to find 3P by 4. So P steel was here. We will be writing this in terms of 3P by 4. And from here, P is this. Okay. Okay. Everybody got it? Let me move to question number 2. Keep sharing, guys. The complete 51 questions will be done today. Complete 51 questions will be done today. Okay. Any doubt here? Okay. Now let me move to the next question. A simply supported beam of length L. Okay. एक simply supported beam थी यार. एक simply supported beam थी जिसकी length L थी और उस पे लोड था sin 3 pi x by L. लोडिंग इस पे था sin 3 pi x by L. Now please let this be A, let this be B. Everybody please check. At x is equal to 0. At x is equal to 0. What is the W? If you put x is equal to 0, so W will be 0 na? If I put x is equal to L by 3, at L by 3, this value will be sin pi. At L by 3, if I put L by 3, L to L will be cancelled, it will be sin pi. Sin pi will be again 0. Sin pi will be again 0. So here it is 0. And at L by 3, at L by 3 it is again 0. And between 0 to 180, it is coming here 0. And at L by 3 it is coming 180. Between 0 to 180, sin is negative function. Oh, sin is positive. Sin 120, sin 130, sin 140, all are positives. So positive, let me take positive as upward loading. You can take vice versa also. Okay, it will be like this, upward loading, because sin is positive. Then at x is equal to 2L by 3. So at 2L by 3, it will become 2 pi. At 2 pi, it is again 0. But from pi to 2 by pi, from pi to 2 pi, sin pi is negative. Negative means downward loading. Negative means downward loading. So it is again L by 3 here, further 2L by 3. And again, at x is equal to L, again it is 3 pi. So again 3 pi means it is 0. And 2 pi to 3 pi, 362, again furthermore 180. Okay, so that will be 540. This is again positive. Positive means upward. Like this. This is a sine function. So the magnitude of vertical, this is symmetrical loading, guys. So symmetrical loading, guys, what is the total area? Total load is area. Total load is area. Area is 0 to L. Function of this sine 3 pi x by L. L इसी के अंदर है यार. L is inside this only. L is inside this only in dx. Okay, so this is the total load, and since it is symmetrical function, so reaction at the left support RA is equal to half of total load as it is symmetrical. As it is symmetrical, so I guess it will be L by 3 pi. Please check. Please check, everyone. Have you got it? I use धीरे सर shortcut. Okay. धीरे सर इसका shortcut भी है क्या कोई?
Okay. L upon 3 pi directly और odd होने के कारण जैसे आपने symmetry बताया, the same thing. Because of that symmetry.
ठीक है. और एक तरफ माइनस हो रहा है, एक तरफ प्लस हो रहा है. ओके, नेक्स्ट क्वेश्चन पे चले. फटाफट. So this is the question number 3, and please let me know the answers on the comment box. Okay, after this question, Dheeraj sir will be coming. After this question number 3, Dheeraj sir will be coming, guys. Fast, fast, fast. Everyone. क्या कह रहा है? A massless beam. Otherwise, if it is not written as massless by default in SOM, everything is Hooke's law is valid. Everywhere weightless is there. If it is not given, then also we'll be taking it massless. The beam is of rectangular cross section with a width of 30 and height of the maximum bending moment पूछा है ना? Bending stress तो पूछा नहीं है, तो इनफैक्ट उसका width और height का जरूरत भी नहीं था. ओके, उसके width और height का जरूरत भी नहीं था क्योंकि bending stress नहीं पूछा है. ओके, फटाफट से बता दो एक बार कमेंट बॉक्स में, फिर मैं बता रहा हूं भाई. फटाफट से. आई एम गिविंग यू जस्ट 30 seconds. प्लीज लेट मी नो. आफ्टर दैट आई एम कमिंग टू सॉल्व दिस. फटाफट से. चलो 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 चलो. ओके, लेट दिस बी आर ए. इसको आर ए ले लेते हैं और इसको आर सी ले लेते हैं. ओके, सो अपवर्ड लोड RA plus RC is equal to 3000 into this is 200 है ना, and this is in mm. All these values are in mm. All these values are in 2000 mm means 200 centimeter, that is 2 meter. So 3000 into 2, that is 6000 Newton. Okay, 3000 Newton per meter and it is 2 meters, so it will be 6000. So RA plus RC is equal to 6000. Now, taking moment about C point, summation moment about C is equal to 0. So RA into 4, that is clockwise, and this is totally 6000. Okay, 6, that is anti-clockwise, 6000, and it can be assumed to be acting at center of mass, that is 1 meter, is equal to 0. So RA value is equal to 6000 by 4, that is 1500 Newton, and RC is equal to 4500 Newton. Are you getting the same values for RA and RC? Are you getting the same values for RA and RC? Okay, now once RA and RC is known, then we can find the SFD. Okay, from AN method or whatever method is your choice. RA upward load, AN method, Abhinav Legi method. Okay, like this. On RC is 4500 Newton upwards. So it will coming down, then only upwards it will be closing. Otherwise, makhi ghus jayegi. Okay, so this will be the SFD. This will be the SFD, and here the value is 1500. Okay, and here the value is 4500. Now those who don't know how I have made this SFD, you can search on YouTube the fastest method on the planet, AN method, and you can do this. Of course, that is not my method, I'm just using it. So 1500 and 4500, this will be the SFD. Now you can find that where shear force is 0. Now you can find by putting the shear force equation that where shear force is 0, because when we are drawing the bending moment, when we will be drawing the bending moment, this bending moment also from AN method, I can draw it just in very fast. Okay, so from bending moment you can find that shape will be like this, and when shear force is 0, the bending moment is clearly here, not minimum, it is maximum here. So when you write the shear force equation at any distance x from here, I'm not wasting the time, I'm just telling you the concept. Okay, when you write the shear force equation, then guys, the shear force is 0 at x is equal to 2.5. At x is equal to 2.5, it is 0. And when I found a bending moment there at x is equal to 2.5, it will be value to puchi bhi nahi hai shayad. The value is not even asked. Okay, so it is 2.5 from to the right of A, that is from here. Okay, so you can just write the shear force equation, put a section here. Let me tell you, from here it will be a shear force at xx. Shear force at xx, that is RA, kahan gaya? 1500. 1500 minus this value. So this value will be how much? 3000 into x minus 2, like this. Okay, and now from here x ki value kahan gayi? 2.5. Okay, 2.5 minus 2 will be 0.5. It will be okay. So from here x is equal to 2.5. It is directly solved. Okay, so got it everybody? समझ आ गया? समझ आ गया? फिर यहाँ से क्वेश्चन नंबर 4 से आगे चलेंगे. अभी धीरज सर पढ़ेंगे इसके बाद. So धीरज सर, now you can come on the screen. So students are very eagerly waiting for you. थोड़ा ज्यादा टाइम ले लिया मैंने सर, सॉरी.
अरे तो कोई बात नहीं.
सर जरा बच्चों को वो प्रेडिक्शन सीरीज और उसका बता दीजिए. थोड़ा बच्चे पूछ रहे प्रेडिक्शन सीरीज और वो फॉर्मूला 1.
Sure. So guys, two series will be starting up just after the marathon sessions. Okay, I will be showing you that that would be better. So from 21st of January, we are starting this prediction series. Like you remember when in the childhood, when you were in the 7th class, 8th class, 9th class, you were going to the teacher. Sir, important bata do. Remember hai? So what that the same thing guys here your faculties would be giving their predicted question which can be the part of GATE 2023. So at that time you were asking, this time we are giving you from our side. Okay. So this prediction series, your favorite faculties will be coming for their particular the respective subjects, and they will give you their predicted question. They can be the part of GATE 2023. And like now marathon sessions were going on where we were doing entire subject. So guys, one more marathon series is coming, that is F1 series. In this only formulas would be shown to you, because at this critical time when exam is just 10-12 days far, you need the formula revisions. Okay, so those two series are going to be started from 21st of January, and both are going to be helpful, and that is the need of time right now.
सर
So
उसमें भी सोम अपन दोनों ही पढ़ाएंगे, दोनों ऐसे साथ में.
Yes. So guys, once again, Abhinav sir and we would be coming for strength of material series.
मेरा सौभाग्य होगा कि मैं आपके साथ पढ़ाऊं.
सौभाग्य हमारा भी है.
सर ये मैं अपना कैमरा ऑफ कर रहा हूँ, ठीक है?
ओके सर.
तो अब मैं कैमरा ऑफ करूंगा, धीरे सर आपको बड़ी सी स्क्रीन में दिखेंगे और फोड़ देंगे क्वेश्चन को.
चलिए guys. So this time guys, this is the question, and once again from SFD and DFD, it is asking you find the maximum bending moment magnitude wise in kilonewton meter for the beam shown in the figure. You can see this is the beam given to you guys. Okay, so A, B, C and D, and you can see there are two support, one is hinge, other is roller. So first of all you will be finding out the support reactions. Okay, so to find out support reaction, you know what we can do, it is overhanging beam. So we will be going with RB plus RD. RB plus RD would be 40 plus 20, 60 kilonewton. What I have done, summation Fy0. Okay, this is equation number 1. Then you can go for summation moment about D. We are taking as 0. So you can see this 20 will be creating anti-clockwise. So minus 20 into. You can see the distance. 3 plus 2, 5. This is 7.5. Okay. Then you can see this RB will be creating clockwise. Plus RB into 5. Okay. Then my dear, you will see minus 40 into 2. That will give you 0. Will give you the value of RB. Once you will get RB, put it here, you will get the value of RD. So once you get these two values, you can go for SFD and DFD very easily. You can solve it after that. So just tell me what are the values of RB and RD, because once we do this, other task is very easy. I will tell you how to move further. Yes. Okay, Abhishek, are you giving the answer for this question? 3.375 kilonewton meter. Let us check. Okay. What about this guys? Tell me, Swapnil, Abhishek, Arun, Naveen, Ajay, Aditya. Okay, very good. So guys, RB is coming out to be 46 kilonewton and this is coming out to be 14 kilonewton. So you got these two values. Now, my dear, if we are going for SFD, I have already made the sign conventions for you. Because maximum bending moment will be at a point where shear force changes its sign. So, you know, if I will be making the SFD for this case, how I will be floating. You know that sign convention is in front of you. You can see to the left, upward is positive. So to the left, upward is positive, downward is negative. I will be having a negative jump of 20. Then there would be a uniform line. Then you have this RB. RB is nothing but equals to 46. So you will be having a jump and you will reach to a value of 26. Then this will remain same, and after that you will be having a downward fall of minus 14 and you will be having this. This is your shear force diagram, my dear. Once you have this as SFD, so my dear, you can see shear force diagram is changing sign at this point and this point. So either at this or this you can find out the maximum bending moment, because they have put the condition that they need magnitude wise. So you need to calculate both the values and you need to see which magnitude is bigger. So I feel you are aware of how we are going to find out the bending moment. If we have this case, okay, this is the diagram of SFD you have. if you want to write the BMD, you can find with the help of the area. How you can write? You can write MD minus MC like that, the area of SM. Likewise, you can find out. Okay, you can start from left hand. Okay, so if you will be starting from left hand side, you will get to know what is the bending moment area at this point, at this point. Obviously, the bending moment at B minus bending moment at A will be this area. If you see this area is 2.5 meter 20. So this value will be coming out to be what? Minus 20 to 2.5. And that will give you the value at bending moment B and bending moment C. You can find out similarly. Either at B or at C, you will get the maximum value. So Abhishek is saying minus 50. As I said, they are asking magnitude. So you need to tell the magnitude. Yes, what about others? Priyanshu already have given the answer. Abhishek already have given the answer. So guys, you are correct. The value of bending moment will be maximum at B. And I am talking magnitude wise, it is 50 kilonewton meter. I will everybody about it. How you can find out? You can write MB minus MA. The area is nothing but 20. Yes, minus 20 into 2.5. So you will be getting the value of MB to be minus 50 kilonewton meter. So magnitude wise, 50 will be the answer. When they are asking magnitude wise, you need to put the answer to be 50. Okay, wonderful guys. बहुत ही बढ़िया, बहुत ही शानदार. Moving to the next question, guys. So this was the first question of mine. Okay. So moving to the second question. This is the second question. This is from deflection. Okay. So guys, very good Ajay, very good Shiva. No, dear. I feel you have done the mistake. Actually, if you will find out at C, this is negative and this is positive. So this, when this is positive, this is 26 into 3. So when you will have 26 into 3, this positive and negative minus values would get cancelled out. So that is why overall at C will be coming out to be lesser only. So if you will find out C, it will be minus 50 plus this. How much this is? 6 into 20, 26 into 3. What is 26 into 3? 78. 78 plus 50 guys, it will be 28. So at C, the value is going to be 28. That is lesser than 50. Okay? I feel you got it. हाँ ये XZ का question है अभिषेक. Okay, next question is from deflection guys. Next question is from deflection guys. This is a frame ABC shown in the figure. Members AB and BC both have a length of L and Young's modulus E. Member AB and BC both have a square cross section of side A. A load P is applied at C as shown in the figure. You need to find out the deflection at C in the direction of load. I feel just by looking at the question, you would have gotten the idea that it is going to be from strain energy method. We can solve it using strain energy method very easily. You need to find out the total strain energy, which would be U of BC plus U of AB. Once you will get this length is L, this length is L. Once you will get this, you know del U by del P will give you deflection at C. This is what you need to do, guys. Okay. For your help, I can see the effect of this force at P by applying one force here, one force here. This and this will be making a couple. When you see this side, this will be making a couple like this. Okay, like this. So this is P into L. You know, because of axial loading, we are not taking the strain energy. We are neglecting that. You would be taking either for shear force or bending moment only. So just solve it and get the answer. Rishabh Pant. Okay. A not sure. Priyanshu is saying A not sure. Rishabh Pant is saying B. Okay. Rishabh Pant is saying by surety. Guys, do check it. I don't feel A and B are right answers. Yes. So guys, whatever the questions we are doing here, they are from mechanical, civil, XC and PI. So 4 branches, best handpicked question we are doing in the class. Just solve it and get the answer. Okay. Yes, guys. So you know, if you will be taking strain energy of BC, you will be taking section here. For strain energy of this, you will be taking section here. Yes. I feel you can do it very easily now. Okay, Ajay, I will try to fix it in the break when Abhinav sir would be taking. Very good, very good. So Abhishek is saying the answer would be D. What about others? Yes, Swapnil, Ajay, Rishabh, Priyanshu, Shiva. So guys, I would say yes, the answer given by Abhishek is going to be the correct one. Yes. नवीन बहुत ही बढ़िया सर डिनोमिनेटर में 3 आ रहा है, कुछ गलती कर रहे हो आप, आंसर वुड बी डी। वो आपका 3 शायद आपने आई की वैल्यू पुट नहीं करी है ऋषभ। ओके, सो आई वुड टेल यू हाउ टू सॉल्व इट। You will be having total strain energy as integration of, for one it is going to be P into x का square dx upon 2ei। माइनस प्लस का ध्यान रखने की जरूरत नहीं है because you know it is square, okay, but still if you want to put it like that you can put it P into L का square into dx upon 2ei। When you will be solving this you will be getting the two strain energies and the value will be coming out to be what? You know, one value is P square L cube, P square L cube upon 6ci. Then it is going to be plus, it is going to be P square L cube upon 2ei. Okay. So by the way, you know that when we are doing this, after adding, you can multiply it with 3 and divide it by 3. So you will be getting 4 P square L cube upon 6ei. What is I? I is A4 by 12. Putting the value, you will be getting the total strain energy, and after differentiating with the load, you will be getting the deflection at C, and that will be coming out to be equals to 16 PL cube upon E A की power 4. That is what you will be getting. Yes. Great. Fine, guys. So I feel everybody understood. The answer would be D. D is the right answer. Is it clear for everyone? हाँ भाई ऋषभ हो गया। Great. So guys, next question is the second part of this, where they are asking you the maximum bending stress. They are asking you the maximum bending stress, my dear. So you know maximum bending stress is given by M upon ZNA. I feel you know bending moment is going to be P into L. Okay, so you know that M is going to be P into L. So putting that value, and for Z they have already mentioned the side is A. Solve it. This is easy question. I feel everybody will be giving right answer for this. Abhishek, Rishabh, Ajay, Swapnil, Doreen. I need right answer from everyone. So 3 questions Abhinav sir have already done. This is third from my side. Overall you have done 6. Okay. Solve it. Yes. What would be the answer? These are top 51 questions, guys. They are going to cover each and every concept of your strength of material. Priyanshu have said the answer to be D. What about others? Yes, Rishabh, Ajay, Swapnil, Abhishek is also saying B. So guys, answer is correct. B is the right answer. So bending moment M is P into L. What is that? It is going to be A cube by 6. The answer is going to be 6PL upon A cube. This is easy part. Right now, nowadays, common data are not coming, but they can ask both the things in one question only. Very good, Rishabh. बहुत ही बढ़िया. Okay, बहुत ही बढ़िया. So guys, अभी I will invite Abhinav sir for the next question. Abhinav sir, please come. I take
Okay, sir.
Question. Yes.
Okay, so guys, 3 questions I have done, then 3 Dheeraj sir has taken, now 7th question. Okay, ऐसे चलते जाएंगे 51 क्वेश्चंस तक। और दोस्तों देखो, प्रीवियस ईयर क्वेश्चन तो आपका प्रैक्टिस हो ही रहा है, साथ में मैं आपको फिर से रिमाइंड करा दूं, वो वैसे 51 क्वेश्चंस हैं that will be covering entire SOM from thin cylinders to deflection to Mohr circle to stress and strain to bending stress, torsion, shear stresses, column, everything will be covered. Okay, so these are hand-picked 51 questions. Now coming back to this question number 7. See, ये क्या है क्वेश्चन? इतना आसानी से शायद आपको फिगर समझ नहीं आएगा, ये पी पॉइंट है उसको समझ नहीं आएगा, तो एक काम करता हूं, मैं इसको थोड़ा सा बेटर आपको एक प्रेजेंटेशन देने का ट्राई करता हूं। ऑल्दो मेरा राइटिंग, मेरा ड्राइंग बहुत सुंदर नहीं है, लेकिन स्टिल मैं कोशिश करूंगा कि कुछ आपको समझा सकूं। ओके, तो आपके पास एक ऐसा वाला ये ब्लू वाला रॉड है, ये है ब्लू वाला रॉड, है ना, ये ब्लू वाला रॉड है। और इसमें जो ये 600 फोर्स आ रही है ना भाई, in which this 600 force is coming na, this 600 force is coming in a very 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 unique manner. This 600 force is coming like this, this is the z axis. Okay, say this is the x axis, this is the x, this is the y, and the axis which is coming to your head from the camera to your head, that is the z axis. So this 600 is coming along the z axis. Okay, now everything, if your body is in equilibrium, then the whole part is in equilibrium. If this whole part is in equilibrium because it is fixed here, so this small part is also in equilibrium. So 600 coming will be here, internal force. Okay, when we cut here, this will be 600. Okay, now this 600, but there will be a movement also. 600 into 500. 600 into 500 will be a movement also. So that will be rotating it like this. Okay, around about this axis, it will be rotating like here. 600 into 500. So for balancing it, opposite side movement will be coming. Okay, this will be rotating here. So for balancing, this will be coming like this. First of all, yahan tak samajh aaya hai ki nahi? Have you understood till here? Then only I'll be going further. If you have understood till here, then only I'll be going further. Have you understood till here? Come on. Okay, just isko hatao. Leave this. This is 600 like this. So for balancing, 600 will be coming here when we cut the section from here. Okay, so this will be rotating like 600 into 500 like this. So okay, so here a movement, opposite movement will be coming 600 into 500. Okay, now if I'm showing this part as the yellow, so here I am showing now the yellow part. Okay, my drawing is not good, but my imagination is a little bit good. So I'm trying to make you understand. And P point is here at the corner. Okay, so this is the P point at the corner. Diameter is 30 mm. Okay, so internal force are always equal in magnitude and opposite in direction. So this is 600. Okay, that is coming here. So here also 600 in this direction, in this z direction, 600. Okay, this is movement is here. So here this will be opposite direction. This will be 600 into 500. Okay, and for balancing here, the opposite forces should be coming. 600 here, so it will be here for balancing. Okay, that is 600 into 500 here. So for balancing, it will be opposite. It will be opposite side. Now, have you understood till here? Please let me know in the comment section. Have you understood till here? Please let me know in the comment section. Thank you, Abhishek Sao, for your answers. Guys, have you understood the free body diagram? Have you understood the free body diagram? Should I elongate this? कैसा होता है ये? Okay, बेइज्जती हो गई. Okay, कोई बात नहीं. होती रहती है. कैसे होता है? Have you understood the free body diagram? Okay. नहीं हो रहा. कोई बात नहीं. Now, if I want to find the normal stress, now see this part only. See this part only. Everyone, see this part only. What are the things that are normal stress? What is the bending on this? What thing is bending on this? Let me just, guys, please give me a while. I'll make you understand. Okay, I know that you have understood. Let me tell you, this is not equivalent to this figure. Like this. Like this. Okay, I'm making this figure here. Now this is cantilever at the end. Okay, now here it is 600 in that direction. Okay, and one is the movement. This movement is like this. That is 600 into 500. So isn't this looking like a torque for this point? Yes, this is torque. And this 600 into 300 is bending. So for point P, M, ये ऊपर दिख रहा है क्या? नहीं दिख रहा. For P, M is equal to 600 into 300 and torque is equal to 600 into 500. Is it so or not? Yes. Then sigma sigma is equal to m by I into y max. Okay, so m is this. Okay, I is pi d4 by 64, d is this pi d4 by 64, and y max, if you see this, what is the from neutral axis, what is the maximum distance? That is radius, that is 30 by 2, that is 30 by 2, is it? No. Okay, so from here you can find sigma. And what is tau max? 16t by pi d cube for solid circular sections. So what is torque? This value. What is torque? This value. Have you understood? Solving from here, you will be getting 67.9 and 56.6. This option. Have you got it? Please let me know in the comment section, guys. Everyone on the comment section. Have you understood this? Yes or no? Yes or no? Yes or no? Okay. Now, after this, the question is the maximum principal stress and the orientation of principal planes. Okay, if I show this P point to you again, then in this P point, I'm enlarging this. The torque, kahan gaya? What are the shear stresses? 56.6. Okay, not going into the directions. The shear stresses tau xy is equal to 56.6. Okay, and the bending stresses are, how much is the bending stress? How much is the bending stress? 67.9. This is 67.9. That is sigma y. And here there is no stress, so it will be 0. Sigma x is equal to 0. From sigma 1, principal stress, sigma x plus sigma y by 2. Sigma x is this, sigma y is 0. Sigma y we have calculated. Plus minus sigma x minus sigma y by 2 whole square plus tau xy square. From here, what principal stress you are getting, guys? I'm not wasting your time in calculations. From here, you will be getting 100 megapascal. And from the formula tan 2 theta is equal to 2 tau xy upon sigma x minus sigma y, or you make the Mohr circle, you will be getting the angle as 60.48. Okay, angle of principal planes from this plane. Tan 2 theta is equal to 2 tau xy upon sigma x minus sigma y. Okay. So I hope you understood this. Let me move now to this question. So this was 7th, this was 8, and now we have moved to the 9th question. Now after this, Dheeraj sir will be joining, guys. Okay, and please don't forget that tomorrow night, our whole team of civil and mechanical will be coming live for you, telling you how to maximize your score in the next 15 or 20 days. Okay, the whole team are coming with their suggestions for you. Now, what is the stress at the corner point P? अब देखो, इसको भी तोड़ के करना है तो कर सकते हैं, इसको भी तोड़ के करना है तो कर सकते हैं, ठीक है? तोड़ के करना है तो तोड़ के भी कर सकते हैं, अदरवाइज थोड़ा डायरेक्ट करना भी सीखो. अगर मैं, if I talk about that part, that green part, okay, if I talk about this green part, okay, if I talk about this green part, now in this green part, this is F, so here the value is F. Okay, ये F directly transfer हो जाएगा. और about P point, if I see, if I take it here, F, and a movement will also be coming, na? This F will be transferred. I'm transferring here, so this will be F, and a movement will be F into L minus B. Okay, so this will be F into L minus B. Okay, so this is the movement. Let me write this movement with a different color. Okay, one is the axial force F, and one is a movement that is F into L minus B. Now, with this F force, okay, sigma will be sigma direct due to this yellow force, and due to orange force, this will be sigma bending. Okay, this will cause the direct force, force by area, axial force, and this will be causing sigma bending. Now, what is the direct force? इसको निकालते हैं भाई, इसको निकालते हैं. So sigma direct is force by area, so F by A. What is the area? 2B into 2B, 4B square. That is the sigma D. And sigma B will be M by I into Y. But before that, it will be plus or minus. Okay? Is it plus or minus? D I feel, because 2 theta is 60. Okay, मैंने calculate नहीं किया है. I have not calculated. If any concept is the same that I told you. Okay. चलो 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 फटाफट बताओ, फटाफट बताओ. 2 theta might be coming 120. Okay. Okay, whatever. I have told you the calculation na. Come on, come on, come on. See, this movement will be causing this part to cause tension here, because it will be something like this. It will be something like this. So this part will be in tension. That part, if अगर यहाँ पे Q होता, ये point, ये होता, तो यहाँ से minus bending होता. But ये इसको इस तरीके से ले जा रहा है कि that part is in tension and this part is in compression. They have asked for the tension, so it will be plus. It will be both same side. Now M into I into Y. So M is F into L minus B. I is BD cube by 12. So 2B into 2B ka whole cube by 12. And Y is the distance from neutral axis. So this distance from neutral axis. So that will be B by 2. That will be B by 2. So how much answer you are getting after solving this? How much answer? वो तो F by 4B square आ गया. यहाँ से कितना आंसर आ रहा है फटाफट से बता दो सबके सब. Everybody, F into L minus B into 2B into 2B cubed by 12. यहाँ से how much you are getting? Are you getting from here? Please explain movement direction. Any other doubt? Okay, after solving this, I'm not wasting again. I'm again saying that I'm not wasting your time in the calculation. You will be getting this. Okay, see, someone has asked the movement direction. Shiva Kumar Yadav. Shiva, I have to transfer this force here now. If I have to transfer this force here, so this will be F. This will be F. And the movement about this point is C. This F will be tending where? That will be clockwise. That is F into L minus B. And when this movement will be here, this will be causing tension here. If you apply the formula sigma is equal to M by I into Y, then algebraic summation of this sigma D and sigma B, you will be getting this answer. Okay, so this is question number 9. Let us go to question number 10 with Dheeraj sir. Okay, Dheeraj sir, you can come, sir.
Yes. So guys, moving to question number 10, once again from deflection part. Okay. So if you see this question, this type of question have been there in all the branches. Okay. In mechanical also, civil also, axial also, PI also. If you see this question, you know how we are going to do this. This is using the concept of principle of superposition. You know, on this beam, P is acting like this. Because of this P, beam will try to deflect. Because of deflection of beam, spring will get compressed. Okay. So definitely spring will be applying some force RS onto this. The same RS will be acting on the spring, and the spring constant, or you can say this K value is also given to you as 3EI upon LQ. And you know how we are using it. You know that this P is creating downward deflection, RS creating upward deflection. So if you are talking about this point to be A, then deflection at A we can write it as this is minus PL cube upon 3EI because it is acting downward. Okay, then it is plus RS L cube upon 3EI. This is going to be the deflection at A. Okay, and you can also write the deflection at A to be minus RS by K, minus for downward direction. Now you know what is the value of K. Both are equal. You will be equating them. And you will say minus P L cube upon 3EI plus RS L cube upon 3EI, that is equals to minus RS upon K. And you know K value is given as 3EI upon L cube. When you will be putting this, you will be finding out the delta spring. Okay, because first of all, putting this value will give you RS. Once you get RS, the delta spring is RS by K. That is what we are looking for. And you need to give the answer what would be the right option. Yes, please choose the right option, guys, and do like and share the session so that other students can also join. Because these are the questions you can never get in one place because they are from different branches, different papers. Yes, what would be the answer for this, guys? These are the options in front of you. Tell me, Abhishek, Shiva, Ajay, Priyanshu. Priyanshu is saying PLQ by 6CI. Okay, Priyanshu is saying B. Abhishek Saul is saying B. Ajay is saying B. Shiva Kumar. Yes. Very good, Shiva. Thanks for that. So answer is going to be B, guys. So answer will be B. That is correct. So guys, wonderful. The best thing is you all are doing it correctly. You all are doing it correctly and giving the right answers. So question number 10 is over. Moving to question number 11 now. Okay. This is easy questions likely. It is from you can say principle or transformation of stresses. A plate in equilibrium is subjected to uniform stresses along its edges with magnitude sigma xx 30, sigma yy 50 MPa. Young's modulus is given to you, and they are saying Poisson ratio is this. Sigma zz is negligibly small. You can assume the stresses in third dimension to be 0. You need to find out strain in zz. You know that strain in zz can be written as sigma zz upon E minus mu times sigma xx upon E minus mu times sigma yy upon E. And you know they have given sigma zz to be 0. If they have given, okay, if they have given sigma zz to be 0, this term will be 0, and you can find out what is epsilon zz. I feel this is easy question, okay? And I feel everyone can answer it. If you are solving it, you can definitely give the right answer. Question number 11 it is. Just solve it, guys. Just solve it. This is question number 11. So we have taken some good questions from all the papers, and all the types are being covered. This type of question was there in GATE 22 paper, also in mechanical paper. Okay. So as I said, we are covering all the types. Priyanshu saying the answer to be A for this. Okay, what about this? Okay. Prudvi saying A. Okay, so first of all, guys, when you will find out, you need to tell me, are you getting it negative or positive? Negative or positive? Negative or positive? Negative. Very good. You will be getting this to be minus 120 into 10 to the power minus 6. So answer will be A for this. Very good. बहुत बढ़िया पृथ्वी. Okay, बहुत ही बढ़िया अजय. बहुत बढ़िया अभिषेक. Moving to question number 12, guys. This is from first chapter, simple stress and strain. Here we are using the formula for deformation of bar. And here they have considered both the bar. This bar is prismatic bar. Okay. And you can see one bar is prismatic, other bar is taper bar. So it is a combination of both the bars, and they are in series. So a tapered circular rod of diameter varying from 20 to 10 mm is connected to another uniform circular rod of 10 mm. Both bars are made up of same material, and modulus of elasticity this load is this. So guys, you know, for this case, what you can do, as the bars are joined in series, this is 1, this is 2. Delta total can be written as delta 1 plus delta. You know the formula for delta 1 is, what is the formula for delta 1? 4PL upon pi E D1 D2. And what is the formula for delta 2? 4PL upon pi E D square. Which D? D2 plus square. You know all the values, put the value, get the answer. You will be finding out the deviation and deflection of A in mm. Just to solve it, guys. Abhishek, Ajay, Prudvi, Ajay, Swapnil, Naveen, Priyanshu. Yes, and Shruti, if you are also there, solve it and tell me the answer. This is question number 12. Question number 12, guys. Yes. Solve it. Question number 12. Solve it, guys. Yes, what would be the answer? Only calculations. P value is going to be same for both, because bars in series. When you will apply method of section, force will remain the same. You just need to put the value and just take the summation. You will get the right answer. Yes. Abhishek, Ajay, Prudvi, Naveen, Priyanshu, Swapnil, Shiva. No, what they are asking? They are asking deflection F, deflection of point A. This is point A, no? They are asking deflection of a point A, which is at the end. So total will be there. Yes. What would be the answer? Solve it, guys. Okay. Fine, guys. Fine. So Abhishek is saying 4.77. Okay. So guys, you need to find out. Okay, very good. I feel Priyanshu got the right answer. So Priyanshu got the right answer. When we will find out delta total, you will be having P4PL upon pi E D1 D2 plus 4PL upon pi E D2 ka square. You will be getting 9 mm plus 6 mm. The answer will be coming out to be 15 mm. Because you can see the value of P is given to us 30 pi kilonewton. Okay. This was question number 12. Okay. So guys, this is question number 13. Okay. After this question, then Abhinav sir would be joining. This is question number 13. Anbumano, I think you have done some mistake in calculation. Yes, 14.7 you can see in the range. 14.7 is in the range for numerical answer type. So I feel some calculation error you have done. So you can see here, consider the three prismatic beams with clamped support P, Q, and R. You can see E value is given, I value is given. They are just asking which of the following is correct. Here S represent the shear force, M represent the bending moment. You can answer in the polls given in the comment section also. So options are there in front of you. This is a very good question, guys. Very good question. So you just need to find out the maximum shear force in this, and this. Then you will get to know which is correct. Maximum shear force and maximum bending moment. That you need to find out. Yes, guys. Let us see how many of you give the right answer for that. Try to solve it. Yes. Strain likha tha. Okay, you have written the strain, but we need to calculate the deformation there. Then it's fine here. Okay, Shiva is saying B will be the answer. What about others? Okay, so majority votes B and C are at equal. Only 7 people have given the votes till now. So guys, if you are going to find out maximum shear force and maximum bending moment, you know, in both the cases we have one end fixed. They are of cantilever nature. So maximum bending moment, when you will find out, you can see this force is 80 Newton into 8 meter. We create 80 into 80, 640. 640 Newton meter will be the maximum bending moment that would be coming at the fixed joint. Here, if you will see, this 20 is acting for 8 meter. So 20 into 8, this is the total load. It is 160. That would be acting at the centroid. So you can say this is at the distance of 4 meter. So it is going to be 20 into 8, 160 into 4. Once again, answer is coming out to be 640 Newton meter. If you see, this is overall 640 Newton meter. So for all the cases, bending moments are same. So my dear, if you see in all the options, B cannot be the correct. Why? Because here they are not equal. So in A and C, all the bending moment are equal. So either A will be our answer or C will be our answer. Now we need to see the shear force. Here, if you will be taking a section, shear force will be coming out to be 80. Magnitude I am writing. Here, if you will be taking a section, shear force is going to be W into X. So guys, 20 into total length is 8. Maximum can go up to 160. Here, shear force is going to be 0. So minimum shear force is there with the R. So if you see here, Here it is shown maximum, so A cannot be the right answer. C will be the right answer. So at Q, you can see this is going to be maximum. Okay. So I feel everybody understood this wonderful question. Everybody got it. Wonderful, guys. बहुत ही बढ़िया, बहुत ही बढ़िया. Okay. So answer for this is C, guys. So now Abhinav sir would be coming from question number 14. Yes, Abhinav sir.
Okay, sir. So guys, this question number 14, a poll is coming to your mobiles, and if you want, you can write answers on the comment section. If you want, you can answer on the poll. The only benefit of poll is that you will not be getting any voucher, but you will be knowing your relative performance with respect to others. This is question number 14, a cantilever beam, and here is a load 10 Newton, and there want what is the stress at the bottom fiber, at this yellow points. Okay, they are not asking stress anywhere, not neutral axis, not at the top fibers. They are asking that what is the stress at the yellow points. One thing is very clear that I can tell on my experience that the question answer cannot be B and D. Okay, it can be easily eliminated. Why? Now you'll be seeing I. Why, guys? What is sigma? Sigma is M by I into Y. Now see, I for all these sections, I for all these sections is same because the dimensions are same. So I is constant. Okay. And for the yellow one, Y is also constant. So for the yellow one at the bottom fiber, Y is 5 mm, the distance from neutral axis. This is again constant. The only thing that is variable, M is the only thing that is varying. Please let me know the answers on the comment section here. Come on. Okay. So M is the only thing, and M is varying linearly here. The bending moment diagram, here it will be 0. Okay, but here is because from right hand side nothing, right hand side nothing, right hand side nothing. So bending moment will be like this. And here the bending moment will be 10 into 1 will be 10. So only thing varying is M linearly. So any linear thing that is M, multiply by a constant, divide by a constant, again will be a linear. So this curve cannot be there. I hope now you get it how I eliminated B on D. How I eliminated B and D. Okay, this is a linear multiplied by a constant, divided by a constant. So this will be sigma will also be linear. Now at here, at the end, sigma at the fixed end. Okay, so this will be M is how much? 10 into 1. Okay, divided by I is BD cube by 12. 10 into 10 cube by 12. Okay, into Y max is 5, so it will be 60. ये 10 को छोड़ो ना यार, मीटर किलो न्यूटन mm कुछ होगा ना यार, एलो किलो न्यूटन मीटर mm कुछ होगा ना, ये 60 तो कहीं नहीं जाने वाला ना, मीटर को mm में बदलोगे, मेगा पास्कल को पास्कल में बदलोगे तो 6 तो कहीं नहीं जाने वाला ना, तो इतना कैलकुलेशन क्या करना है? डायरेक्ट A will be the correct answer. Have you got it? Okay, so 53% have opted for A. Now ये कौन सा था? 14th question number, 3 6 9, फिर सर ने 4 कराए 13, 14 था ये, और ये होगा 15th. ओके, चलो दिमाग दौड़ाओ इस पे फटाफट से. Okay, these are two cantilever beams. Okay, and this is jointed here like this. So once the deflected shape of them will be something like this. Deflected shape of them, if I make, the deflected shape will be here. Okay, at this hinge, this will be a discontinuous thing, discontinuity in slope. Okay, and if it is in equilibrium, इतना बड़ा P force नहीं लगाया कि ब्रेक ही कर जाए. We have not applied that much big force that this breaks. Okay, so deflection will be same. Okay, deflection will be same, slope will be changed. Like my hand is like this, na? If I do like this, then the slope, the deflection here, just left of this and just right of this is same. Just left, just right. Only the slope is changed. Here it is almost 0 slope, and here it is an angle. Okay, so at this point, equal deflection but not equal slope. Okay, now, but see, ये भी एक assumption के हिसाब से, अगर ये P इतना बड़ा लोड हो जाए ना कि ये तो टूट जाए, ये ना टूटे, ये सपोर्ट ना टूटे, तो इसकी डिफ्लेक्शन भी अलग हो सकती है कि ये तो टूट गया फिर नीचे पहुंच गया. But unless mentioned, we assume the support to be rigid if it is mentioned. Okay, so this was question number 15. That this is question number 16. Let me check here. Who can do this? This is the real question, yaar. I want to check it personally that who can do this question, because only the students who can get a double digit rank, only the students who can get a double digit rank can solve this. Okay, let me check who are the double digit rankers in our class right now in the midnight. Right now in the midnight. Okay, galat de diya poll. I have given the wrong poll. Only two options. Only two options. कितना दिमाग खराब हो गया मेरा. Okay, फटाफट से everyone. Okay, and see, I don't waste time in giving polls and everything. I know that this question requires time. So जब तक I am creating, I have created also. Till I am creating the poll, you can do this. This is the real question, and anyone who is solving this, in my vision, he is the real champion of SOM. He is the real champion of SOM. Okay, so if this is a green thing, this is the green thing, and this is the yellow thing. This is the yellow thing. They are fixed here. It is also fixed here. Now, if I make this green thing, and in this green thing, here is a P. Of course, it is in equilibrium. So from here, the internal forces, let me make with the blue color. Let me make the internal forces with the blue color after cutting the force. This will be P, and a movement will also be coming PL. Okay. See, now for this green, because for this green, if I take a section here, XX section, that is X distance from here. What is the strain energy? Strain energy is mx square dx upon 2EI. Of course, the shortcut that I told you can apply that also. But every time I am telling you shortcuts, so I am telling you from the long cut now. Okay, shortcut bataya tha. Please watch my shortcut of strain energy also. Okay, so here it will be P square x square dx upon 2EI. Okay, so U is equal to U of this green. I am saying U of this green. भाई ये U green का था, green वाला U ये green वाला था. Okay, so green का तो P square तो constant हो जाएगा, 2EI will be constant, and x square integration will be x cube by 3, and it is from L cube. So P square L cube by 3, so it will be P square L cube by 6EI. This is the strain energy of green one. P square L cube by 6EI. Yes, Rishabh, P square L cube by 6EI. Now going for the yellow one. So first of all, let me make the free body diagram of yellow one. Internal force always equal in magnitude and opposite direction. If this is upward P, this is downward P for balancing it. This is a PL in that direction anti-clockwise. So this is a PL in clockwise. Okay, this is the PL in clockwise. Let here the reaction be R. Okay, let here the reaction be R, and I don't know if this force will be coming something or not. Let it be R dash. Okay, so these are ये तो इसका opposite चला गया, and this is R, and for balancing, of course, this will be also R. Okay, now guys, summation of movement about any point has to be 0. So this is A, this is B. That is the strain energy of AB. Okay. Now this is C. So summation of movement about C is equal to 0. So this P is passing from there. So 0. This R is also passing from there. This is PL. So this R has to be opposite to make it balance. Okay. So R into L. Okay. Plus PL, both are clockwise. So it is 0. So R is equal to minus P. Okay. R is equal to minus P. That means these directions will be reversed, and both will be same because summation fx has also be to 0. Okay, so Abhishek देख लेना यार please. Strain energy में पूरा detail में बताया तो that these all things are not required. Very fast you can do this. Okay, that is integration of m del m del. You can see this here. Okay, now if I take a section from here, xx, that is again at x section. The R value is equal to P in opposite direction. Okay, then strain energy of this. What is this? BC. This yellow part. U of BC is equal to the bending moment at x distance, P into x. Okay, p into x ka whole square into dx upon 2 ei and integration from 0 to L. Again, same expression is coming. Here also the bending moment is px, here also bx. Ei is also same. Everything is same. Okay, so here ubc is also equal to p square L cube into 6 ei. Okay, why I am doing this? Why I am calculating the u of both? Why I am calculating u of both? Because in the expression del u by del p, for delta del u by del p, that u is total, not of a single part but of a whole structure. That u is a total synergy. So u इसका पीले का कितना हो गया? p square L cube by 6 ei, उसका भी 1/6. तो total हो जाएगा p square L cube by 3 ei. Okay, because in the formula that I am going to apply now, deflection is equal to del u by del p. This u is total synergy, total. Okay, so let me check the poll here. Let me check the poll of the students. Let me check the poll of the students. Aja. Okay, 40% opted for D. Okay. So it is del u by del p and u is a total synergy. And when you differentiate this with respect to p, so it will be 2p. 2 by 3 it will be coming, na? 2p L cube by 3i. 2p L cube by 3. And this deflection is here two things. U is the total synergy, that of green and yellow both for the whole structure. And this deflection is in direction of P. This deflection is the direction of P. And here also they have asked the vertical deflection. If they ask the horizontal deflection, then a pseudo load in the horizontal direction has to be applied, P dash. And del U by del P dash has to be found out. At the end, P dash has to be put as 0. Okay. So, guys, this was question number 16. I hope you enjoyed this, guys. Okay, so B was the correct answer and 30% had opted for B. एक और कर लेते हैं. Question number 17, guys. Fast. Okay, in a load P, the beam, the value of the slope at the free end. Let this be at free end A. Okay, so theta A due to this P load is PL square by 2 EI, simple formula. And due to M, it is ML by EI. So PL by 2 into L. This is M into L by EI. So it is PL square by 2 plus PL square by 2, that is PL square by EI. This was question number 17. Question number 18 is also Lallu. Very easy. That is why cantilever beam of length L with uniform cross section EI loaded by vertical load. Okay, W vertical load hai, but that is W per unit length. That means UDL. The maximum vertical deflection is here WL4 by 8EI. Okay, again Lallu question. Okay, 19th question. Okay, torque wala, but let me ask Dheeraj sir to come and then we'll be moving forward. Okay. Dheeraj sir.
Yes, sir.
सर अपन पूरा एफर्ट लगा रहे हैं पर बच्चे उतने हिसाब से क्या करना है सेशन लाके बच्चे का इतना रिस्पॉन्स ही नहीं है बच्चे देखना ही नहीं
मुझे लग रहा है कि ये लोग आराम कर रहे हैं आराम से मतलब सो गए हैं है ना और हम लोग जाग रहे हैं
ठीक है सर आप कंटिन्यू कीजिए
तो सर आपने 18 कर दिया ना 18
हाँ सर मैंने 18 कर दिया अब आप 19 से
यस so guys now we are moving with 19th question ये है question number 19 and what it says two triangular wedges are glued together as shown in the figure the stress acting normal to the interface sigma and they are asking okay and you can see the state of stress किस तरीके का state of stress दिया हुआ है you can see that they are giving this is tensile and second one is compressive so you can see for this case what is this plane and for that plane you need to find out sigma n that is at an angle of 45 degree चलिए देखते हैं कितने लोग सही आंसर करते हैं प्लीज टेल मी गाइस so guys do like and share the session okay so that others can also join still 50% more than 50% questions are left yes Abhishek Ajay Okay. No issues, Abhishek. We will be sharing that video, and that is given in the YouTube channel. Abhinav sir have taken few days back. Okay, you can check it. So what would be the answer for this, guys? You need to see. Okay. Abhishek is saying answer is 0. What about others? This is easy question, but you need to just think. This is from principal stress, Mohr circle, transformation of stresses, that chapter. Yes. So we have not taken all questions difficult, some are tricky also. Abhishek is saying 0. What about others? I'm waiting for others answer. Priyanshu, what would be the answer? Swapnil, what would be the answer? Yes, yes, yes. Swapnil. Okay, Ajay is saying answer to be 0. Okay. So guys, what we need to see first of all, whenever you have this type of state of stress, first of all, you already know that this is going to be the principal plane, this is going to be the principal plane. And if you're going to plot the Mohr circle for this case, you know on X phase, you have the state of stress to be 100, 0. On Y phase, it is minus 100, 0. So guys, we are having on X phase, this is the point. On Y phase, this is the point. Okay, sorry, I have made it wrong, I feel so. So it should be coming on to the x-axis. Yes, I'm making it again. So you are going to see this is on x phase 100, 0, y phase minus 100, 0. So these are 2 points. When you will be joining them, this will be the joining line. Take this diameter, make a circle. This circle is Mohr circle. So if you are saying very good guys. So when we are talking about this is the Mohr circle. So dear, I feel you have done it wrong, Ajay. All planes are principal plane is not true. So if you see this is one is tensile, other is compressive. This will be the Mohr circle. And if you are talking about 45 degrees from the X phase, you will reach to the 90 degree Mohr circle. And if you're talking about this point, for this normal stress is 0, shear stress is maximum. So if you see this at 45 degree to the principal plane, this is tau max plane. This is plane of maximum shear. But when center of Mohr circle comes to the origin, plane of maximum shear and plane of pure shear, they coincide. And at plane of pure shear, normal stress is going to be 0. So guys, the answer for this is no doubt about that is 0. Moving to question number 20, guys. Once again, we have some Mohr circles given to you. Which of the following Mohr circle qualitatively correctly represent the state of plane stress at a point in the beam above the neutral axis? So if we have a beam like this, okay, you are having this as neutral fiber, okay. Okay, neutral fiber, okay. If you make the cross section, this is going to be neutral axis. Then they are asking you what? They are asking you where it is subjected to combined shear and bending compressive stress. Combined shear and bending compressive stress. Okay, so you need to tell the state of stress of this point. For this point, they have also mentioned that compressive bending and shear stress is acting. For this, what would be the Mohr circle? Which would be the right Mohr circle? Okay, Ajay, that is fine, no issues. So Ajay, please tell me the answer. Andumano, please tell me the answer. Swapnil, tell me the answer. Options are there in front of you. So you can see that if you are going to see X phase, this is X phase. The state of stress is minus bending, and this is going to be anti-clockwise minus tau. And if you see the Y phase, on Y phase sigma is 0 and this is plus tau. When you will be plotting X phase and Y phase, X phase point will be coming on to the minus, negative side. So definitely when you will be plotting this, how you will be searching the point? Minus sigma b minus tau, minus sigma b minus tau will be coming out to be somewhere here. And 0, plus tau will be coming out to be somewhere here. Join these 2 points and take AB to be diameter, plot a circle. Yes, the circle will be coming. The circle will be coming like this. Okay. So you would be having which one is correct? A, B, C, or D. Wonderful, Abhishek. बहुत ही बढ़िया, Ajay. So the answer is going to be C for this. C for this. Why the C is the answer? Because one point is coming somewhere here. Second point is coming somewhere here. This is A, this is B. When you will be joining this AB and taking AB as diameter, you will plot the circle. This will be the Mohr circle. So the answer is no doubt about that is C. C is the right answer. Yes, very good guys. Yes, Priyanshu, आप है कि नहीं? Swapnil, very good. समझ आया कि नहीं? This is question number 20th. Moving to the question number 21st. ये भी थोड़ा सा आसान क्वेश्चन है. So guys, this type of questions are coming every year in the paper. So the time which is being asked, we are here with those type of question only in front of you. So this is question number 21st. An element is subjected to biaxial normal tensile strains. This is normal tensile strains of this and this. The normal strain in the plane of maximum shear strain is. You need to find out the value of normal strain at plane of maximum shear. तो plane of maximum shear पर normal strain बतानी है आपको. What would be the answer, guys? Please tell me. Do like and share the session, guys. Still we have not completed 25 questions. More than 50% questions are pending. Yes, tell me, guys. Ajay, what would be the answer? Abhishek, what would be the answer? Anumano, Swapnil, Priyanshu. Yes, everyone. What would be the answer, guys? What would be the answer? Solve it and tell me the value. Okay, Sumit is saying B, Abhishek is saying 0.0025, Ajay is saying, okay, B and D. There is a fight between B and D. Some are saying B, some are saying D. So guys, you already know that when we are talking about plane of maximum shear, okay, if we are plotting the Mohr circle like this, when we are talking the plane of maximum shear, at plane of maximum shear, normal stress is given as sigma xx plus sigma yy by 2. You need to find out normal strain. So it would be epsilon xx plus epsilon yy by 2. So guys, answer will be coming out to be D for this. Okay, D will be the right answer. I feel everybody got it. Am I correct or not? D will be the right answer. Rishabh, बहुत ही बढ़िया. Sumit, you have made some mistake. I feel you understood now. So the answer for this is going to be D, but not the B. Okay, D is the right answer. Moving to question number. Okay, now I will request Abhinav sir to join for question number 22nd. Okay, we have done up to 21. So now Abhinav sir will be coming and yes, Abhinav sir.
कहाँ से अब 20?
21 हो गए सर. 22 से आप करेंगे अब.
22 से. ओके, कितने करा दूं सर मैं डायरेक्ट?
सर करा दो 26-27 तक.
26-27 तक ठीक है. ओके, 26-27 के बाद 50 तक आप डायरेक्ट. चलो दोस्तों करते हैं फटाफट से. अब दिस क्वेश्चन इज दैट द टॉर्क इज कमिंग T हियर, सो ऑफ कोर्स अपोजिट टॉर्क विल बी T फ्रॉम हियर सो दैट इट इज नॉट रोटेटिंग लाइक अ sugarcane juice machine. Okay, if that T is here, that T will be in opposite direction. Okay, guys, if both T will be in the same direction, then there will be no twist, there will be rotation. Okay, let me tell you. Said torsion chapter is same like the first chapter. Now, if the both are P here now, then there will be no deflection. It will be accelerating with the 2P force, and acceleration will be 2P by M. Okay, even if there is only 1P, there will be no deflection in this. Okay, it will be accelerating with force by mass. Okay, so the deflection only comes, the strain only comes when this is like this, both P in opposite direction. Similarly, if the both torques on a shaft are in the same direction like this, so it will be rotating with the infinite angle, continuous rotating like this, like this. If both torques are in the same direction, if this is here and this is here, then the twist will be coming. Okay, so guys, like delta is equal to P by K, similarly the twist is coming to be T by K, T by torque by torsional stiffness. Now guys, here the torque from left hand side is 10, here also 10, here also 10, so torque is constant. Okay, so we want to find out the angular deflection between the ends M and P. So phi from M to P is equal to phi from M to N plus phi. इसका कभी मतलब सोचा है कैसे हुआ है ये? Let me tell you. If this is a long rod, long rod, imagine. And the angle between here is, between this hand and this hand is 2 degree. The difference between them is phi AC is 2 degree. And with respect to CD is further by 5 degree. So then A to C is 7 degree. I hope you got it. No. Suppose the phi between the phi AB, this long shaft, and phi AB is 2 degree. With these two hands are rotated by 2 degree. And then here, again with respect to this is rotated 5 degree. So with respect to initially it is rotated by 7 degree. Got it? So from the same here, we have written this. So phi Mn is T by K. So what is T? 10. And what is K of Mn? 10 by 20. Similarly, phi is same. Phi is same, that is 10. And what is K? 30 plus 10 by 60. So you can take LCM as 60. You can take LCM as 60. So this will be 30, 50 and 10, 70. 30, 50 and 10, 60. So is it coming 1? Please let me know. Is it coming 1? 60 by 60? Okay, B option. Excellent. Excellent. ऋषभ पंत तबीयत कैसी है? एक्सीडेंट हुआ था ना रुड़की में, सब सही? Okay. So just kidding. So the two shafts AB and BC are there. Of course, A and C are cantilever, built-in support. They are cantilever and they are joined by a coupling here. Now, what does coupling mean? Can you please let me know? Coupling क्या होता है यार? What is coupling? What is coupling? Okay. Can you please let me know what is coupling? These two are fixed support. Here the diameter is D. Here the diameter is 2D. What is coupling? Let me write the question number also ना. Sir, ये question number कौन सा था? 22. ये 22 था ना? Okay, so ये 23. Okay, so what is coupling? Nobody is replying. Nobody is replying. Coupling means a boy and girl. Okay, coupling is that it will make equal twist at that particular point. Okay, coupling will means if this is A, this is C, that means coupling will make it sure like that phi AB is equal to phi BC. This is the effect of coupling, that it will make two shafts together. Yes, Abhishek, and phi AB will be equal to phi C. Now, what is phi AB? Suppose here the torque is coming TA, and suppose the torque here is coming TC. So TA into length upon GIP. G is G only. IP is pi by 32 into D की power 4. Length is here again G, pi by 32, and here it is 2D की power 4. Okay. Material same है क्या? Two shafts AB and BC of equal length and diameter are rated as same material. Same material, that means G will be same. Same material, that means G is same, L is same. Okay. Pi by 32 is same. Okay. Okay. So here it means that TA is TC is equal to 16 TA. That is option number C, and it was question number 23. Okay. Good, Rishabh Pant. Okay. 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 Now, question number 24. So a pin end column of length L, modulus of elasticity is this. Okay, I is loaded as eccentricity by compressive load of critical. See, the critical formula is n square pi square E I minimum upon L effectives ka square. Okay, actually it is n square. You don't study n square, you don't directly study pi square. N is the number of buckling loops. N is the number of buckling loops. Okay, suppose the column is like this, and you apply the load here, and you apply the load here P. So here the deflection will be something like this. So N is equal to 2 here. Okay, but usually in our case, if nothing is mentioned, we don't assume that this support is here, and we assume N is equal to 1. We assume N is equal to 1, so it will be pi square EI upon L square. Okay, because it is to both sides column na, both side pin, and L is the distance between 2 points of contraflexures. Okay, L is the distance between 2 points of contraflexure. So here also 0, here also 0. So L effective is equal to L. This was question number 24. Let me move to the little higher part of, okay, little difficult part of this column chapter. Now this is the question. Now let me see that who can do this. Come on, Abhishek Sahu. Okay, so it's okay, it's okay. D कैसे? Pi square EI upon L square. N square. Okay, sorry. Okay. So कहाँ गए? क्या बोल रहा था मैं? हाँ. Now let me check this यार. अभिषेक, साहू, ऋषभ, पृथ्वी, नवीन, सुमित, everyone. I want to check this question. Come on. This is question number 25. I want to check this question. Okay, I don't know that, guys. See, PCR is equal to n square. If n is not given, hero नहीं बनेंगे हम. Pi square E I, and both sides are hinged, so it will be L square. Okay. Now here the P is the compressive load. I don't know that how much load is going here. I don't know how much load is coming here. I don't know. Let the load going be P. ये अच्छा question है भाई. Let the load going here is P. Okay, let the load going here is P. If this is P, then P ka horizontal component is F, and P sin 45 will be the vertical reaction that will be balanced by here. So cos 45 is 1 by root 2. So P cos 45 is F. So what is P? P is F root 2. Please check. Everybody. Come on, everyone. Kitna answer aaya? Have you got the answers? Okay. Now, this root 2F is pi square EI upon L square for failure. निकालना क्या है? What is the maximum value of force of F? F का आपको बताना है कि कितने फोर्स पे मैक्सिमम तो क्या इनफिनाइट पे भी टूट जाएगा. मैक्सिमम तो क्या क्वेश्चन पूछा है इसने? मैक्सिमम मिनिमम पूछना भाई. मैक्सिमम तो बोलेगा तो मैं आंसर इनफिनाइट दे दूंगा कि F पे इनफिनाइट पे टूट जाएगा, एंड दैट इज मैक्सिमम. ओके, सो आंसर विल बी करेक्ट. सो हियर इट शुड बी मिनिमम. सो F is equal to pi square EI upon root 2 L square. That is option number C. ये समझे क्या? Have you got this answer, guys? And guys, don't be going anywhere else. Tomorrow night, the whole team of civil and mechanical are coming. To tell you about the upcoming 15-day strategies to optimize your marks according to your capability, according to the syllabus covered by you. Okay, and prediction series and the Formula 1 series will be coming day after tomorrow. Okay, every teacher with a vast experience of more than 10 plus years, they will be telling you some questions that are expected. We are not guaranteeing, we are not Rajnikant. Okay, and Formula 1 series. And also, guys, please don't go anywhere else. Okay, we'll be coming on 27, 28, 29 with Maths Marathon, Maths, Aptitude and English Marathon. And on Saturday and Sunday, Maths Marathon on app. Kahan gaya? Okay, 25th. Let's do a couple of these small questions. Let's do small questions. Then Dheeraj sir will be taking this. Okay, guys, keep sharing the video. Everyone here, come on. B hoga. How B? Root 2F hai na? So root 2 will go down. Now, so the maximum shear stress is, guys, what is, suppose this is A, suppose this is B. Now what is TA and what is TB? So TA is equal to T naught into this distance 3L by 4 by L. So this is T naught, 3T naught by 4. And what is TB? TB is T naught, this distance L by 4 into L. So this is T naught by 4. So this is the maximum torque and it will cause the maximum shear stress. Tau max is 16T by pi d cube. Okay. Why this will cause maximum shear stress? Because diameter and every other thing is same. So wherever the torque will be maximum, that will be causing. So 16 in T is T naught by 3. So 48 by 4, that will be 12. So 12 T naught by pi d cube, that is option number B. Okay. Mock test hoga na. I told at the initial, yaar. Mock test will be there, yaar. Guys, let me tell you. Okay, mock test will be there. Prediction series will be there from 21st, then Formula 1 series Okay, mock test on 22nd and 26th both. 22nd and 26th both. Okay, for civil also 22nd and 26th both mock test will be there. This Saturday, Sunday, guys, please there will be a mock test of civil and mechanical both. And this marathon will be next weekend, 27, 20, 29. And this weekend will be a app that also a poster that will I show you. This is also at the end. That poster will be there for maths marathon aptitude app. Okay. So कहाँ गया 26 था. So 26 is this. Okay. Then 27th. So what is column has a rectangular cross section. This slenderness ratio is close to. So lambda is the slenderness ratio. What is the significance of slenderness ratio? More is the lambda, more is the buckling, more is the chances of buckling failure, not crushing failure. So bigger lambda represents long column and it represents the more chances of buckling failure. So both sides are pinned. So L effective will be the length only. That will be 1 meter. 1 meter in mm. I am calculating everything in mm. Now R minimum. What is the physical significance of radius of gyration? What is the physical significance of radius of gyration? If more radius of gyration of a shape of a body, that it represents that on a particular area. From a particular area we can make circle. From a particular area we can make triangle. From a particular area we can make a rectangle. We can make I section. We can make L section. We can make irregular shape. For a particular area which gives the maximum I, that means strong in rotation, that is more radius of gyration. So radius of gyration represents that a particular area more moment of inertia. Okay, so I is kitna hoga I? BD cube by 12. Okay, I minimum. So it can be 10 into 20 cube by 12 on about one axis, and about another axis is 20 into 10 cube by 12. Okay, it is 10 into 20 cube by 12 about one axis, and about other axis is 20 into 10 cube. So of course the minimum will be 20 into 10 cube by 12. Ab answer bata do yaar, I am not having calculator. So 20 into 1000 it will be this divided by 12. Okay, so 12 1 ja 12 80, 12 1 ja 12 80, 12 6 ja 72. Okay, 12 1 ja 12 80, 12 6 ja 72, again 80, 6 something like this point something. Okay, now once approximate बोला है ना उसने, अच्छा approximate, अच्छा close to, हाँ 16 6 का कितना होगा? 40 into 40 is 1600. 41 के आसपास, 40 के आसपास, तुक्का लगा रहा हूँ, 40 41 के आसपास. एंड इसको 40 से डिवाइड करोगे तो आंसर गलत आ जाएगा. क्या गलत आ गया? वो तो आ गया 20 आएगा. 200 तो नहीं आ रहा, 200 तो नहीं आ रहा है, 200 तो नहीं आ रहा है. बी कैसे बोल रहे हो? बी कैसे बोल रहे हो? यहां से कुछ गलती किया क्या मैंने? रूट आई बाय ए 20 इंटू आई क्यूब बी इंटू है सर.
ए की वैल्यू भूल गए सर.
अच्छा ए की वैल्यू भूल गया. बताओ कितना बेवकूफ हो गया हूं मैं. 200 से डिवाइड करेंगे. सो 200 से डिवाइड करेंगे तो ऊपर 100 बचेगा. अब मैं अप्रोक्सीमेट निकाल रहा हूं, मेरे पास कैलकुलेटर नहीं है. 200 से उसको डिवाइड करेंगे तो 100 बचेगा. 100 बाय 12 करेंगे तो 8 12 8 96, 8 पॉइंट समथिंग आएगा, है ना. तो 8 12 100 के आसपास आएगा ये. ओके, उसको 100 बाय 12 आएगा, तो 100 बाय 12 आएगा तो ये वैल्यू आपके पास आएगी 8 पॉइंट समथिंग, है ना. 8 पॉइंट समथिंग आएगी. और 1000 को 8 पॉइंट समथिंग करोगे तो कितनी वैल्यू आ रही है? जो भी आपके पास आएगा. आई एम नॉट वेस्टिंग टाइम इन कैलकुलेशन. ओके, whatever you will be getting, that will be the correct answer. So this is question number 27 and 28 now. Dheeraj sir will be taking. And guys, please share the video, yaar. Come on.
Yes. So guys, question number 28 we are at. Okay. So guys, you can see two faculties अपनी नींद खराब करके आपको पढ़ा रहे हैं और आप लोग इंटरेस्ट नहीं ले रहे हो. And I remember in all the groups you guys were saying when that PYQ session will be there. आज है तो लग रहा है जोश सिर्फ फैकल्टीज में, स्टूडेंट्स में ही नहीं. So guys, be regular and be there till end. क्योंकि कुछ स्टूडेंट शुरू में थे, अब लग रहा है वो क्वेश्चन सोल्व कर ही नहीं रहे. So let's move to the next question. That is question number 28. For a given loading on a rectangular plane concrete beam with an overall depth of 500 mm, D is given to you as 500 mm. Then they are saying the compressive strain and tensile strain develop at the extreme fiber R. They have given you the value of strain also 2.5 into 10 to the power minus 4. And they are saying the curvature. You know, R is the radius of curvature. And my dear, 1 by R is the curvature. So you need to find out 1 by R. Okay. And I feel all of you are knowing the bending equation. Everyone knows the bending equation. Sigma B by Y, that is E by R. Okay, when you are going to use this, you can also write it as sigma B by E is into Y is equals to 1 upon R. You know, sigma B stress by E can be written as strain. So strain by Y is equals to 1 upon R. So guys, this is what you need to find out. 1 by R. 1 by R is nothing but strain by Y. And you know that both are given to us. What is Y max? This is D by 2. Okay. So putting this value, Y is D by 2, strain is given to you. You will be able to find out the curvature. The units is there in meter inverse. Tell me the answer, guys. What would be the answer for this? So look at this comment section. Joshi sir is also there. So दो नहीं तीन लोग आपके लिए जान रहे हैं. All faculties are giving that much for you guys. Just make the heart for Joshi sir also, like he is here to motivate you guys. So guys, थोड़ा motivation खुद से भी बनाकर रखो, ठीक है? What would be the answer for that? Every time we are always there to help you guys. Always, you can see. Yes. So guys, tomorrow we will be having the orientation session for the new series, prediction series, Formula 1 series. Be ready for that. Okay. Tomorrow 10:30 p.m. all your favorite faculties would be there at this platform once again. Solve this question, guys. Abhishek, what would be the answer? Ajay, what would be the answer for this? Tell me the answer for this question. Question number 28. Question number 28. Yes. Very good. Ajay have given the answer this time. So answer is going to be 1 into 10 to the power minus 3 meter. Very good, guys. बहुत ही बढ़िया. So Ajay have given the answer. Yes. Anbu Mano also have given the answer, and the answer is correct, guys. So when they ask curvature, it is 1 by R. When they ask radius of curvature, it is R. Moving to question number 29, guys. Moving to question number 29. Yes. This is a simply supported beam of reinforced concrete beam of length 10 meters sacks while undergoing shrinkage. Assuming a uniform curvature, this time they have given 1 by R is 0.004 meter inverse. The maximum deflection of the beam in midspan is. So guys, you know this is the beam. Okay, this is the beam. And after deflection, it is the part of this circle. I feel everybody aware that if I take this diameter, so you know this is going to be your deflection. And what is that? This part is 2R minus 1. I feel everybody knows the property of circle. This is L by 2 and L by 2. You can write L by 2 into L by 2. I feel everybody knows the property of circle. When a diameter is cutting a chord. So if this is A, this is B, this is C, this is D, this is E. What we can write? We can write AC into BC is equals to DC into CE. So that is L by 2 into L by 2 is equals to Y into 2R minus Y. You know that deflection is very, very less. Y square is going to be still lesser. So guys, Anki Joshi sir is also with us. I feel entire team is just watching. Students are preparing or not. Students are serious or not. So what else you need, guys? All faculties are there for you all the time. You can see at midnight faculties are there to motivate you. So this is going to be L square by 4 is equals to 2YR. You can find out the Y value as L square upon 8R. Just put the value, get the answer. This is a deflection, guys. I feel everybody can find out the answer now. Yes. Wonderful, guys. So what would be the answer for this question 29th? We will be moving to the next question then. Yes. Ajay, what would be the answer? Abhishek, what would be the answer? Please tell me that. Yes. Rangu Mano, what will be the answer? The question is there in front of you. The data is there. Formula is there. Okay, Rishabh, this is the property of circle. When you were in 8th class, 9th class, 10th class, then you have studied this property. You may get forgot. If one diameter is cutting a chord, then you can write. If this is you can use this property. This is the property of circle. This is the property of circle. Property of circle. Yes, I feel you got it now. Ajay and Anbu Bano have given the right answer. And the answer for this is going to be 0.05 meters. That is true. Answer is correct. This was question number 29. Moving to the question number 30th, my dear. So these are some more slides which are saying something. As you already know, sir, I have already told you 27th, 28th and 29th. You would be having verbal ability, mathematics and general ability. So Joshi sir, Richa ma'am and Ankit Joshi sir. These faculties are going to take these three things. And 3 Champions Day marathons would be there. You can cover your general ability part. And from 11th February, the students who are looking for ESC paper 1, after the gate examination of both the branches, we would be having ESC paper 1 classes. So marathons of ESC paper 1 are also planned for you guys. Moving to next question, guys. Question number 30. This is from deflection. You can use Maxwell's reciprocal theorem here. What would be the answer, guys? Do it fast. Do it fast. So this is Maxwell's reciprocal theorem. Maxwell's reciprocal theorem. Okay. You can apply this. What is the question saying? Question is saying for the cantilever beam of span 3 meter and concentrated load of 20 kilonewton applied at free end causes a vertical deflection of 2 mm at this section. If this is A, this is B. They are saying that load at A is 20 kilonewton. Deflection at B due to load at A is 2 mm. This is the given data. And then they are also saying that if a concentrated vertically downward load of 10 kilonewton is applied at the section, so they are saying if WB is 10 kilonewton, then what would be deflection at A due to load at B? That is what you need to calculate. And I feel everybody would be aware of what is that reciprocal theorem. That is WA into Y at A deflection and WB and deflection at B due to load at A. So you know the data are given to you. WA is 20, WB is 10, this is 2. Out of 4 things, 3 are given to you. 4th one can be found out. What would be the answer, guys? Just solve it. Just solve it. 3 are given, 4th you need to calculate. 3 are given, 4th you need to calculate. Just put the value, get the answer. This is 20 kilonewton. Y at A you need to find out. And that is equals to 10. And if you see that, the next one is 2. So you can find out the deflection at A due to load at B. That would be your answer. Yes. I feel you have made mistake. Anbu Mano, but Rishabh has given the right answer. Very good, Rishabh. बहुत बढ़िया जा रहे हो आप, बहुत ही शानदार. So guys, the answer would be coming out to be 1 mm. Yes. Abhishek, are you there or not? Have you done it or not? So answer will be 1 mm. This is a very good question. And this is from deflection of beam. Yes, moving to the next question, guys. Question number 31. Yes, this is the question number 31. Okay. So guys, if you are going to see this question, there are 2 loading conditions given. One is you are having UDL on this beam. Second is the point load at the center. And you need to tell if this is deflection, the center deflection in this case is delta 1, in this case is delta 2. Then you need to tell what is correct out of these 4. whether they are equal, unequal, what is the case. You can see here the length is 4 meter. You can see here the length is 4 meter and here the length is 2 meter. So length is different. So you can see two prismatic beams having same EI value. EI value is same. Mid-span deflection of these beams are delta 1 and delta 2. The correct option would be, what would be the right answer? Guys, please tell me that. Yes, I feel for that we have seen the values, because in the table you have seen delta 1 will be given as 5 WL4 upon 384 EI. Yes, this is for delta 1. So delta 2 is, what would be the delta 2? PL cube upon 48 EI. So I feel everybody is aware that force is 160 kilonewton here, W is 6 kilonewton per meter here. You need to check whether they are equal or something is bigger. Rishabh Pant is saying answer to be A, it means delta 1 is equal to delta 2. What about others? This is question number 31. What about others? What about others? Yes. What about others? Only Rishabh is solving. What about others? Tell me guys, tell me. So when you will be putting the value of W, value of length and value of P, then you would be getting the relation between delta 1 and delta 2. And you will be finding out guys, delta 1 to be equals to delta 2. So it means the answer given by Rishabh, A is the right answer. Moving to the question number 32, my dear. Moving to the question number 32, my dear. This is from columns. This is from columns. Consider two axially loaded columns, namely 1 and 2, made up of linear elastic material with Young's modulus of the square cross section. Length is 1 meter. Column 1 is 1 end fixed, other end free. This is column 1. And column 2 is 1 end fixed and other end is pinned, like this. Like this. And you need to answer that the ratio of buckling load of column 2 to that of column 1. You know that when we are writing the buckling load formula, it is L square pi square EI minimum upon LE square. Every other thing is same. Only the difference is in LE value, my dear. Only in LE value. Very good, Ajay. So if you see this case, for this case, LE is 2L. And for this case, LE is what? For this case, LE is what? LE is L by root 2. So you need to tell which one is going to be the right answer. So you just need to take the ratio of P2 and P1. What would be the right answer? What would be the right answer, guys? Rishabh, Anbu, Ajay, Abhishek, प्रांशु, स्वप्निल, मैं उन सब लोगों का नाम ले रहा हूँ जो सोल्व कर रहे थे क्वेश्चन. शायद उनमें से कुछ लोग अभी भी बैठे होंगे. So tell me the answer, guys, for this question. This is question number 32, and we will be having next question once again from the simple stresses topic. Okay. Yes, we are covering all the types question, guys. Tell me, guys. Fast. Yes. Arey bhai, you know that you need to find out P2 by P1. You can see P is inversely proportional to alpha square. So you can see P2 by P1. P2 by P1 is L1 ka square by L2 ka square. Yes, putting this value, what you will be getting? Putting this, what you will be getting? Yes, you would be getting 8. Because L2 is L by root 2. So the answer will be 8. Very good, Ajay, your answer is correct. Very good, Anbu Mano, your answer is correct. Answer is 8 for this. 8 for this. बहुत ही बढ़िया. And guys, बिल्कुल similar question in 2022 भी आया है. In GATE 2022 भी आया है. बस उसमें boundary conditions अलग थी. So this is the next question, guys. This is the next question. A wooden block of length 400 meter mm, width 50 mm. This is question number 33. Okay. So after this, Abhinav sir will be joining once again. So you can see everything that is mentioned to you. This angle is given as theta. If you remember, when we have done this derivation and we have seen this value is P, we have taken the angle, this angle as theta. But here this angle is given as theta. So I am considering if this is theta, this is phi. Phi is nothing but 90 minus theta. You know that for this case, we were finding out the normal stress to be P by A cos square theta by cos square phi. And they are asking you the value of sigma n2 by sigma n1. What is sigma n2 and sigma n1? Actually, this angle is changing. How this angle is changing? Theta is changing. You can see initially theta was 30 degree and then theta was 120 degree. So when theta is 30 degree, phi will be 60 degree. And when theta is going to be 120 degree. Theta 120 meaning, what is the meaning of that? It means the plane will become like this. At that time, this angle, if this is 120, this is 60 and this angle will become 30. It means phi will become 30 for the second case. This is first case, this is second case. And you need to find out sigma n2 by sigma n1. So it is nothing but cos square 30 divided by cos square 60. This is what you need to do, guys. Tell me the answer. Hint is there in front of you. I feel everyone can do that. Very good, Bishwaji. बहुत ही बढ़िया, guys. So after this question, your favorite Abhinav sir would be joining. 33rd question is going on. Okay. And yes. Okay. Anbu is saying root 3. What about others? Okay. 1.73 is root 2. Root 3. What about others? Yes, Vishwajit, Ajay, Rishabh Pant. Ajay is saying answer to be 3. And I will say Ajay's answer is correct actually. So answer is 3 because I feel Anbu Manu, you have done this mistake. You have not seen this square. If you would have seen this square, you would have given the right answer. So answer would be 3 but not root 3. Okay. So I feel you got it. So Abhinav sir, please join for question number 34.
Okay, sir. Okay. So now it's question number 34. Okay. So guys, how is the Josh? I hope yes, many students are still there and still solving. Eunice Anbu. Dheeraj, sir, Eunice Anbu is the same student who got the prize also in the maths marathon. SOM marathon. Yes, Ajay, Rishabh. Okay. So, guys, fantastic, everyone. कुछ reply कर दो, थोड़ा सा इज्जत दिखा दिया करो टीचर को भाई. Okay. So, sir, कौन सा 34 है ना? हाँ. So now we'll be taking the question number 34. Ajay, what about others here? Come on, please let me know in the comment section. How's the Josh at 1 a.m. in the morning in this cold weather? Okay. So the expected angle twist at the free end. Suppose this is B and suppose this is A. So phi AB is given as phi B minus A. Suppose B is twisted by 3 degree. A is also twisted by 3 degree. So both are twisted by same amount. So there is no twist in between. Okay. So there is no twist in between them. So it will be 0. The relative twist between them is 0. And if one is twisted by 7 degree, other is twisted by 5 degree, relative twist is 2 degree. Okay. If 7 and 5, of course, are in the same direction. Otherwise, it will be 12. 7 minus 5. Now, phi A, it is logged. It is fixed end. So it will be 0. Okay. Phi A is logged. So it will be 0. Now, we want to find out now phi A, the expression to produce at the angular twist phi at the free end. So phi B we will be finding the expression to produce the angular is, it should be phi, na? Okay. So phi AB can be written as phi AC plus phi CB. Phi AC plus phi CB. So what is phi AC? If you cut it here, it will be torque T into L is L into GIP, that is pi by 32 into 2d ki power 4. Okay, 2d ki power 4. And what is phi CB? If I cut it here, it will be T into L is L by 2 into G into IP, pi by 32 into d ki power 4. And summation of both of them is phi AB. Phi AB is phi B minus phi A. Phi A is 0 and phi B is given as phi or theta. Okay. So theta we want to find out, and this is the expression. Now 32TL, and we want to find the expression for to produce an angular twist phi torque T stepped circular bar. The shear modulus is G. The expression to produce an angular twist phi. Okay. The expression नहीं होगा, the diameter D की वैल्यू निकालना होगा, शायद D की वैल्यू निकालना होगा. ठीक है. So from here, if see, I'm not wasting time in calculation. From here, if you find the D की value, it will be coming as 18 TL pi theta G की power 1 by 4. That is option number B. I'm not wasting time. D have they asked. Okay. Okay. So this was question number 34. Now 35. In 35, what they are saying, that a simply supported beam of span 6 meter. Okay. Simply supported beam of span 6 meter. Like this. And diameter carries a diameter nahi diya. Okay. And diameter value dena padega na. Diameter tum मान लो D. Diameter तुम D मान लो. फिर D के आंसर में आएगा. फिर इसको छोड़ दो. फिर D के ऑप्शन में आएगा. Okay. So it will be 1.5. तो कैसे सॉल्व करना है ये बता देता हूं. बेंडिंग मोमेंट मैक्सिमम कितना आएगा? WL square by 8. Bending moment maximum will be WL square by 8. Okay. So bending, what is the maximum value of bending moment? So bending moment will be WL square by 8. Okay. See, आंसर आ जाएगा. मेरे को लगा बेंडिंग स्ट्रेस पूछ रहा है, तो मैं ज्यादा ही आगे पहुंच गया था. बेंडिंग स्ट्रेस पूछ रहा है, तो बेंडिंग स्ट्रेस के लिए तो आपको बताऊंगा, उसका बताऊं. पहले बेंडिंग मोमेंट बताता हूं. So bending moment will be WL square by 8. Okay. So WL square by 8. What is W? 1.5. L square 6 square by 8. So 36 into 1.5 by 8. 36 into 1.5 by 8. 36 into 1.5 means 36 plus 18. For 54 by 8. So 54 by 8. 8 is 8 6 ja 8. 8 6 ja 8. Okay. So what's the answer coming? It's Patafat say 6 point something, and answer is not there. Answer is not there. There WL square by 8. So W is 1.5. L square is 6 square. Okay, by 8. So WL square 36. 36 into 1.5 is 54. 54 by 8. Okay, so this is the correct answer. So none of these will be there. Okay, this might be the bending stress. Then for that diameter has to also given. Okay, then for that diameter has to also given. Okay, because the maximum bending stress will be M by I into Y. Okay, for sigma max, M will be maximum, I will be pi d4 by 64, and Y will be d by 2. Okay, so it will be like that. Now moving, this was question number 35. Now 36. 36. In 36, what they are asking, a solid circular shaft ABC has a total length of 3A. Okay, ABC has a total length of 3A. Now, the gear wheel positioned at B at a distance A from the left hand A. This is A, this is C, and this is B. So this length is A and this length is 2A. Now, A and C are locked. A and C are locked means they are fixed. Now, and a torque is applied at B. Okay, the left hand A exerts a torque T. A from left hand exerts a torque. Here it is T. Okay, so now they are asking what is the ratio of torque T1 and T2. Here is the torque T1 in this zone, and here is T2. So T1 by T2 they are asking. What is T1? What is T1? T into that 2A upon 3 upon total 3A. So 2T by 3. And what is T2? T into this TA by 3. So that is T by 3. So that is 2:1. That is 2:1. That is option number D. Have you got it? Have you got it, everyone? Have you got it? Any doubt, please let me know. Okay, and guys, tomorrow 10 a.m. math session is also there in this YouTube channel only. In this YouTube channel only by maths by this Ankit sir. Okay, then next weekend will be the marathon. Next weekend will be the marathon of English, aptitude and maths. And this weekend will be the maths marathon on app. And this weekend also we are having a mock test also. So many sessions for you according to your choice. You can see according to your requirement. This was 36. Now 37 is the MSQ. 37 is the MSQ. Everyone, please let me know. Everyone. Okay, the value of bending stress will be 0. Sigma is equal to the bending stress value is equal to sigma is equal to m by I into y. So at neutral axis y is equal to 0. So y is equal to 0, so sigma is equal to 0. Extreme fibers of the simply supported beam. So when it is simply supported beam and with any loading, whether it is UDL, point load, distributed load, uniformly varying load, okay, m at the ends is 0. M at the end is 0. Okay, so m at the supports is 0. So not the center, but yes, at the support, because at the support m is 0. So for any y, if it is y max, if y minimum, it is 0, it will be 0 at supports. Okay, so A and C will be the answer. This was 37. Let us go to the question number 38. Let us go to the question number 38 and let me know your answer. Okay, the cross section of a beam is shown in the figure. The cross section is like this. Its IXX is also given. It is subjected to a load as shown in the figure. The maximum tensile stress in the beam is. Okay, the maximum tensile stress is asked. Tensile stress is asked. Okay, so what is the shear force diagram? Like this, like this, like this. It is symmetrical na. So this will be also 0.3. This will also be 0.3. Okay, then here, then point like this. This is the shear force diagram, SFD. Now BMD if I make, guys, so BMD will be like this. So bending moment maximum. This is BMD. Now what is bending moment maximum? Bending moment maximum is 0.3 into 3. So 0.3 into 3 is 0.9 kilonewton meter. This is the maximum bending moment. Okay. Now what is the maximum bending stress? That is m by I into y. So for sigma max, m is equal to 0.9. I about the bending axis is 3 into 10 to the power 6 into y. Now the two choices will be there. Can you tell me? We will take y as 50 or 65. Y max will take 70 or 50. Guys, this is a negative bending moment. Negative bending moment will means hogging. Hogging means tension at the top. Hogging means tension at the top. So irrespective of y max value, we'll be checking that where it is tension because they are asking the tensile stress. So y max will be rating as 70. If they ask for compression, then we'll not be taking this as 70. We'll be taking y max as 50 in that case. We'll be taking y max as 50 in that case. Have you got it? Have you got it, guys? Please let me know on the comment section. Every one of you. Every one of you. Have you taken it? Okay. Let's move to the question number 39. This is the question number 39. In question number 39, the stress resultant in the XY. This is the previous year question. In this XY segment, this is P. So on this XY na, this is the XY. The P is directly over it. The P is directly over it. So it will be only axial. It will be only axial. For other parts, yes, the movement will also come. Bending or torque, that depends, that they have to show us the 3D figure at which point they are asking. But yes, on the XY segment, it is directly over it. There is no eccentricity, so it will be only axial loading. This was 39. Let's move to the question number 40. Let's move to the question number 40. Everyone, please let me know the answers here. Come on, come on, come on. Subscribe the channel, guys, for more such sessions. Everyone. Come on. Come on, friends, everyone out there. What they are asking, the BMD दे रखा है भाई, है ना? BMD दे रखा है और पूछा है कि इस बीएमडी में क्या हो रहा होगा, तो मेरे को लग रहा है ना बीएमडी में देखो यहाँ पे एम का जंप हुआ है, और जंप तभी होता है जिसने एएन मेथड पढ़ा है एसएफडी बीएमडी का, जब कपल होता है। तो यहाँ पे एम का जंप हो रहा है, यहाँ पे माइनस एम से प्लस एम भाग रहा है, तो 2m का जंप हो रहा है। तो m at c और 2m at d, ओके, m at c एंड 2m at d, बिकॉज उतने का ही जंप होता है जितना वहां पर आपके पास कपल लग रहा होता है। गुड मॉर्निंग एवरीवन गाइस। ओके, चाय वाय बना दूं भाई? 40 था ये। अब चलते हैं 41st क्वेश्चन पर। अब चलते हैं 41st क्वेश्चन पर। ओके, 41st क्या कह रहा है? एक कैंटिलीवर बीम दे रखा है इसने, और a load of 10 kilonewtons applied at the midpoint. The magnitude of bending moment, magnitude पूछा है सिर्फ, है ना? तो ये लोड कितना होगा? RQ, that is hinge. So bending moment at P is equal to 0. So 10. Okay, as per Mike sign convention, what I told that this is downward loading we take as negative, and if even for left or right, it will be negative. It will cause always hogging. 10 into 0.5. And upward will always be sagging if it is from left or right anywhere. Okay, RQ into 1 is equal to 0. So RQ is equal to 5. RQ is equal to 5. And now we want to find the moment at O point. So bending moment about O point, RQ, that is 5 into 3. So it is upward, so positive, and minus 10, right hand side only two things are there, one is this, one is this. 10 into 2.5. So 15 minus 25 is equal to 15 minus 25 is minus 10, but they are asking only magnitude. Okay, minus plus nahi they are asking, they are not asking minus or plus, they are not asking minus or plus. Now this was question number 41. So now this is again MSQ. This is one of only those questions that is not a PYQ. This is only one of those questions that is not PYQ. So if guys, the question is like this, always see, here there is a boat. So here there is a load of 80 Newton. And if it is written in the question that is symmetric boat, if it is written, then there will be upward beyond load. Okay, it is symmetric, so it will be W Newton per meter. As boat is in equilibrium, there is no support. Bhai, cantilever nahi hai. There is no cantilever, nothing like this. There is no support, no reaction, no movement. Only the water is providing the upward thrust. And total upward load is W in 1 meter. So in 2 meter, it will be 2W is equal to 80. अगर भाई डूब जाएगा ना, summation Fy 0 नहीं हुआ. Summation Fy 0 नहीं हुआ तो डूब जाएगा ना, तो W is 40 Newton per meter. And as per Abhinav Negi, AN method, that is not my method. I always, whenever I say AN method, I tell that this is not my method. Just for fun, I say this is AN method. That is the method of SOM from many years. Okay. So, but yes, I am using this from many behind. Dhiraj sir is also using. Okay. So that is not my invention. So upward and this is what? Upward loading as per AN method, positive and constant. So like this, like this. This is the SFD. Just see the AN method. If you have not seen, you can draw SFD, BMD in just 2 seconds. So positive increasing like this, this negative, you can see, then you will understand. From that, you can understand. So guys, always guys, SFD linear, BMD will be quadratic, and SFD will be anti-symmetrical, BMD will be symmetrical. So only A and B. And guys, always remember for every symmetrical beam which has symmetrical supports and symmetrical loading, SFD will always be anti-symmetrical. Like this. Okay, SFD is anti-symmetrical. BMD is always symmetrical. For every symmetrical beam which is symmetrical in loading, supports, loading and supports, it is anti-symmetrical SFD and BMD symmetrical. Like this. It is symmetrical, SFD is anti-symmetrical, BMD is symmetrical. Okay, so A and B will be here. So this was question number 42. This was question number 42. Now, question number 43. What is compliance? What is compliance? See, delta is equal to PL by AE for prismatic bar. So stiffness of that bar is P by delta. That is AE by L. Opposite of stiffness is compliance. Okay, that is flexibility also. L by AE. Opposite of compliance, opposite of stiffness is compliance. LAE. It depends on L, A, and E. Okay, many students know this, but many of you are not knowing compliance. Everybody knows the stiffness. So this was question number 43. Now question number 44. Okay, now after this, Dheeraj sir will be taking. Question number 44. The bending moment at E would be. आपसे पूछा है यहाँ पर bending moment. Okay, the bending moment at E would be. First of all, let this be RB. I don't know the direction, just taking it anyway. Okay, so summation of movement about any point is 0. So RA, okay, RA into 1, 2, 3, 4 clockwise. So it is positive. Then 2 is anti-clockwise, minus. Okay, this is not, I'm not writing the equation of bending moment. I'm writing the equation of movement. So using the movement sign convention, that is clockwise positive, anti-clockwise negative. Okay, so 4 into RA, this 2 is anti-clockwise, minus 2, this 2, again anti-clockwise, 2 into 3, minus 6. This 4 is again anti-clockwise. This is not hinge, I've just shown E point. 4 into 2, 8. This 2 in minus 2. And this 2 is clockwise, plus 2 is equal to 0. Calculation check कर लेना यार. Please check calculation. Please check calculation यार. 6 और 2 8 8 16 16 और 2 18 6 और 2 8 8 8 16 16 2 18 माइनस 18 हो जाएगा तो प्लस 18 16 16 RA 4 आ जाएगा और पॉजिटिव में आ रहा है मतलब मेरा मामला सही चल रहा है. सो RA 4 आएगा एंड 2 नीचे 4 नीचे 2 नीचे 2 4 5 6 8. So 4 and this will also be 4. Now bending moment at E. Calculation, please check my calculations, guys. Bending moment from right hand side and left hand side, your choice. Let us see from right hand side, this upward load, bending moment sign convention now. Bending moment sign convention. So upward load positive, 4 into 2, 8. So this 2 downward load, minus 2. And sign convention of this, section right hand side, clockwise is minus. Okay, minus 2. So 4, in this positive, that means sagging. That means sagging. Yes, Ajay. So this was question number 44. This was question number 44, guys. And guys, this is tomorrow. Tomorrow in the night. Very, very important session, guys. Okay, for all the students who are giving the GATE 2023, we whole team are coming together for tell you that what is your optimum and how you can achieve that. Okay, mock test will be on 22nd, 26th for civil and mechanical both. Civil and mechanical both. The mock test will be this. The predictive series that will be from 21st. Marathon series will be again from F1 series again from 21. Okay, and guys, this is on app. This is on app, the Maha Marathon for 8 hours of complete engineering mathematics. Complete engineering mathematics will be done, guys, on 21st and 22nd January. This will be on app by Rakesh sir and Ankit Joshi sir. This will be a non-tech marathon after your GATE class for those students who are giving for engineering services. And this is again a complete marathon. Just like I told you now, this will be 27 January, that is Friday of Richa ma'am by English. English किसी ने नहीं पढ़े मेरे को पता है. Then 28th will be engineering mathematics. Then 29 will be aptitude. This is complete engineering mathematics in one shot. Complete engineering aptitude in one shot and in verbal ability. 27, 28 and 29. And this, your favorite, Dheeraj sir. Your favorite Dheeraj sir will be here along with me. And this will be the countdown begins GATE 2023. Here we'll be telling you some very, very important do's and don'ts before giving the GATE examination. And that will be not very simple do's and don'ts that you are thinking right now that no new syllabus and this. That will be very intense and deep research do's and don'ts. Okay. So guys, till now I'm again coming. We are again coming with the questions. For 44 is there. Now for other questions again, 5, 45, 6 questions are left. We are taking this, guys. Don't go anywhere. We both are here till question number 51. Now Dheeraj sir is there with question number 45, and Dheeraj sir, I have taken long time, so sorry.
Okay sir, so guys, now we are here with question.
Okay sir, बोला सर, आपने ये भी नहीं बोला कि कोई बात नहीं.
जी मुझे लगा आप दोबारा आओगे ना.
नहीं, दोबारा तो आऊंगा. दोबारा मैं तो यही हूँ सर. अभी और क्वेश्चन कर लेंगे जितने आप चाहेंगे.
आप देख रहे हो कि किस तरीके से मिड नाइट में चल रहा है सेशन. And so guys, for you guys, you have seen in comment section all the faculties, Abhinav sir and Joshi sir and Ankit Joshi sir, every faculty was there for you guys. So guys, now we are moving with question number 45. In this, a shaft is given, a torque is given, axial load is given. You know that this is a case where you can find out the axial loading by putting P upon area. You will get the axial loading like this. And to find out the maximum value of shear stress, you know you need to do T by ZP. That will give you the maximum value of shear stress. So this is the axial loading, this is the tau max, because P is given to you, T is given to you. And this is the value of pi is also given to you. Okay. So guys, now you know that this is the state of stress where we have this as axial loading, this as axial loading, and this as the tau max. Okay. So you know this is the case of combined loading, but in the question they are asking you the maximum tensile stress. It means you need to find out the principal stress sigma 1, 2, where you will write sigma xx plus sigma yy by 2 plus minus square root of sigma xx minus sigma yy by 2 ka square plus tau xy ka whole square. You can see here sigma xx is nothing but sigma a, sigma yy is 0, and tau xy is t by zp. I will putting the values. You can find out the value of principal stress. Ajay, Dipanshu, Anubumalo, yes. What would be the answer, guys? This is question number 45. Still, we are left with 6 more questions. So let us see how many of you give the right answer for this. You need to find out the principal stress. What would be the answer for this case? I will be helping you guys when you find out tau max. You would be getting the value to be 40 MPa. This will be coming out to be 40 MPa. And when you are going to find out the sigma value, sigma and normal stress, sigma axial, that would be coming out to be 60 MPa. So you need to use these values and you can very easily find out the answer. So guys, anybody, are you trying this? Yes, Durgesh. What would be the answer? So guys, good night and good morning. How are you? Session is still going on. Please tell me what would be the answer, guys. So when you will be finding out this sigma 1, you know sigma xx is 60, this is 40. Putting this value, you would be getting the principal stress to be 80 MPa. Yes, the answer will be coming out to be 80 MPa. So the answer will be coming out to be 80 MPa. So maximum normal stress, which is principal stress, is 80 MPa. Okay, I feel everybody got it. Yes, Ajay, Anbu Manu, are you there or not? This is the once again your favorite Mohr circle, question number 46. I feel this is very easy to answer. I will wait for your answer in this question. You can feel one thing. This is the center of Mohr circle, and this distance is given to you as 20. And you are given this distance to be 40, and you can see this distance is given as 30. So you need to find out what is the normal stress at point A, what is the normal stress at point B, what is principal stress 1 and 2. So guys, just solve it and give me the answer. This is question number 46. 5 more questions after this. Durgesh, Dipanshu, Ajay, Anbu, yes, this is towards completion, guys. Now, just जाते answer करिए, बताइए. Complete करते. Yes, Dipanshu saying D would be the answer. Okay, let us see. Dipanshu saying D is the answer. So if you see the point A, this is the point A. If you find out any stresses are measured from the origin only. So when you will be measuring it from the origin, this is the origin. So sigma A is this value. So if you see this value, this is 20 this and 30 this. It is going to be minus 50. So we get to know sigma A is minus 50. So first of all, C and D cannot be the answer. We are having A and B. The possibilities are either A or B. Then my dear, you can also see one more thing, sigma B. What is sigma B? You can see that this is the sigma B. So you need to see this is the sigma B. This value is the sigma B. So you also get to know right now that if you see this value is 40, this value is 30. So you will find out the radius to be 50. If radius is 50, you will be going to see this distance is 50. If this is 50, out of this 20 is covered here. So my dear, in that case, if 20 is already covered here, this total up to this is going to be 30. So if that is going to be 30, obviously from this to this, if you are already found out sigma A, this is 30. So obviously guys, this is total going to be 30, out of which 20 is covered. So this value is 10 only. So you will be having sigma B to be 10. Sigma B to be 10. Okay. So sigma B is 10 only in option A. So guys, only option A can be the right answer for this case. And if you will find out sigma 1 and sigma 2, you know that sigma 1 is going to be this value. When we find out this total radius is 50, this is going to be 30. And if you will be adding, this will give you the sigma 2. Up to this it was minus 50. You know that radius is 50, this is 50 plus 20. It is going to be minus 70. Although they need not to be calculated, still I have done it for you. No issue, Ajay, no issue. So the answer for this is A. A is the right answer for question number 46. Moving to question number 47. This is very easy question. Ajay, I am expecting Ajay, Dipanshu, Durgesh, you all will answer this. Anbu, Manu, yes. Question number 47. Just look at the state of stress from all the sides. 100 is coming. 100 is coming. 100 is coming. This is the case about which Ajay you are talking about. This is the hydrostatic state of stress. For this hydrostatic state of stress, what would be the Mohr circle? For this hydrostatic state of stress, what would be the Mohr circle? Very good, Ajay. So for this, what is the Mohr circle? Mohr circle is going to be a point. And you will be having the principal stresses to be minus 100. And as the Mohr circle is a point, radius is 0. So tau max is 0. Very good, Dipanshu. Answer is going to be D. This type of questions have been asked 3 to 4 times. That's why I have taken this. This was question number 47. Moving to the question number 48, once again for deflection. 48 is once again from deflection. This time they are saying this is a cantilever beam on which at this point a bending moment of this is acting and a force P is acting. And they are saying if this is point A,
Okay. So guys, I think sir video has been paused. It will be corrected soon. Okay. So till then you can ask me doubt if you want have any doubt. Okay. 48th क्वेश्चन पे थे सर, है ना? तो 48 सर ही करा देंगे, तब तक जब तक सर का लाइट आता है तब तक मैं 49th कर देता हूँ आपके लिए, है ना? मेरे ख्याल से लाइट या ऑडियो कुछ इश्यू होगा तो गाइस ओके 49th क्वेश्चन मैं कर लेता हूँ, ठीक है? आपको प्लीज 42 वाला यार आप में से कहाँ गया? ये वाला ठीक है, इसमें क्या दिक्कत है? 80 डाउनवर्ड लोड आ रहा है, ऊपर से उसको यूडीएल लगेगा क्योंकि इसने क्या रखा है कि सिमेट्रिक बोट है, ऊपर से यूडीएल लगेगा, इसका एसएफडी बीएमडी बनाओगे तो ऐसा बन जाएगा, ठीक है? ओके, सर का कौन सा क्वेश्चन था मैं भूल गया, सर का कौन सा क्वेश्चन था? 48 था क्या जो सर करा रहे थे? 48 था क्या जो सर करा रहे थे? था, तो ठीक है मैं 49th करा देता हूं। आपको ये दे रखा है और आपसे पूछा है कि सिग्मा 1 कितना होगा, तो सिग्मा 1 होगा सिग्मा x प्लस सिग्मा y बाय 2, सारी वैल्यूज दे रखी हैं, प्लस सिग्मा x माइनस सिग्मा y बाय 2 होल स्क्वायर प्लस टाउ एक्स वाई स्क्वायर, है ना। तो सिग्मा x कितना है 110, सिग्मा y कितना है 30, तो 140 बाय 2 कितना हो जाएगा 70, प्लस ये तो रेडियस ही होता है, रेडियस का ही फॉर्मूला है, तो ये कितना होगा 110 सिग्मा x माइनस 110 माइनस 30, 40 का स्क्वायर प्लस 30 का 50, सो सिग्मा 1 हो जाएगा 120 एंड सिग्मा 2 में इट विल बी 70 माइनस 50, तो इट विल बी 20 और रेडियस विल बी 50, तो जो भी ऑप्शन है वहां पर, है ना। तो वट एवर द ऑप्शंस आर देयर यू कैन डू दिस। ओके, सो दिस वाज क्वेश्चन नंबर, सर ने आपने कहा कि दैट वाज 48, तो दिस विल बी 49th। ओके, नाउ two questions I am framing myself, although I have more questions for factor of safety, I have more questions, but I want to frame myself. Question 50, आंसर बताना ध्यान से आंसर बताना। This is a cube. Here the stress is sigma z, that is 20 megapascal. Okay, this is 35 megapascal. Okay, and here in this direction the value is 70 megapascal. So sigma x is compression, that is 35 compression, sigma y is 70 tension, okay, and sigma z is 20 compression. Mu is 0.3. Volume will A increase, B decrease, C constant, D can't say. Tell me please. Tell me please. Tell me please. Everyone. Every commando. Tell me. This is question number 50. Volume will increase or decrease or remain constant, or we can't predict. If mu is equal to 0.5, I know many of you will be saying 0. That is a very ordinary question. That is a very ordinary question. I am asking this. It will increase or decrease. Guys, see. The volumetric strain is sigma x plus sigma y plus sigma z into 1 minus 2 mu by E. Okay. For mu is equal to 0.5, this will be 0. So no volume change, like for rubber. And if sigma x plus sigma y plus sigma z is also 0, if this is 20, this is 35, so compression 20 and 50, and this is 55, then again 0. If it is mu 0.5, then for any values of this it will be 0, no volume change. And if mu is something else and sigma x plus sigma y plus sigma z is 0, then also the volume change is not there. And if sigma x plus sigma y plus sigma z is positive value, like it is minus 20, minus 35, minus 55, but plus 70, so net is plus 15. So in that case, volume will increase. Are you knowing this first time, or you know already this question? Now, leave this. Question 51. Question 51, everyone, please see here. Suppose this is a simply supported beam loaded with UDL. Okay, cross section is rectangular. Okay, neutral axis is this. Okay, now I am taking this point. Okay, leave this. Okay, take this point. Oh, leave this. Oh, this is 3. This is L by 2. Now, how the stress element 3 looks like? How the stress element 3 looks like? How the stress element 3 looks like? Please see. Option A. Option B. Option C. Option D. Please let me know. Please let me know, everybody, how the stress element looks like. Everyone on the comment section. Okay, guys, I think there is a technical glitch. Light, white, everything is fine there. Internet is also fine. He is not able to join in the Zoom. I don't know the reason. There is some technical glitch. So, guys, the correct answer here will be this. Okay, रात के 2 बज रहे. Okay, the correct answer will be, guys, 3 will be no shear stress. Both answers, 2 answers. First, at 3 there is shear force is 0. At 3 shear force is 0. So जो shear stress पैदा करता है, that is 0. And even if there is shear stress, even at some other point there is shear stress, at top and bottom shear stress is 0. So here the both answers are there. If shear force is 0, it cannot come. And even if here at this section the shear force come, at bottom and top shear stress will be 0. Okay, and it is sagging, so it will be tensile. No force from y direction in vertical direction, because it is UDL and it is small point. It is W Newton per meter. It is W Newton per meter, and this is a point. The length of point is almost 0. So per meter W, in 2 meter 2W, in 3 meter 3W. In this small length it will be W into 0. It is almost 0. Okay. Yes, I already told Dhiraj to students. Okay. So guys, this I told you. This will be tomorrow, guys. Okay. And then 22nd and 26th for civil and mechanical both, Saturday and Sunday. Sorry, 22nd and 26th. It will be a this क्या कहते हैं इसको mock test. Prediction series is there, as I told you. My formula 1 is there. This also I told you already. App marathon of mathematics. Okay, this I also told you, non-tech marathons. And this will be on 27th, 28th and 29th, maths, verbal ability and general aptitude session. And this me and Dhiraj will be taking. The countdown begins. Have you enjoyed this session, guys? Please let me know in the comment section. I hope you all enjoy. Okay, thank you, guys. Good night. Good morning, we can say. It's 2 a.m. in the morning. Okay, so good morning. Okay, thank you, guys. Take care. See you soon. Thank you.